Hello everyone, very good evening. Kindly confirm if audio video is clear. Hello. Good evening everyone. Please confirm if audio video is clear. All clear. Okay. Thank you. Sorry for this delay. I was facing some electricity issue because of a project is going on. So anyway, let's begin the session. So yesterday we could complete only two topics, that is relational model and normal forms and query languages. So we'll discuss the PYQs of those two topics only, and remaining we'll cover in the Mahabhyas. So we'll see the questions along with the topics in the Mahabhyas. So that's what we planned yesterday. Okay. So we'll see the PYQs of relational model and normal forms, relational algebra, and structured query language. So these are the three topics that I have chosen. So please try to understand that the questions will be damn easy from the chapter relational model and normal forms. Most of the time people will struggle with query languages. So we'll focus more on the query languages and we'll see that what are the different types of questions that has been asked in the GATE from this topic, relational model and normal forms. So we'll be we'll be able to solve each and every one of those questions. So don't worry about that. So which of the options given below refers to the degree of a relation? So these are the type of questions that may be asked. Okay. So I mean, so I'll not be wasting times on this particular thing. So we all know that the degree of a relation is nothing but the number of attributes in that particular relation. So number of, come on, who is saying B? Nitesh, how come it can be B? Who said B? So it's damn easy that number of columns or number of attributes in a relation. Sorry, I've just went in the flow of B along with you. So number of attributes in the relation will define the degree of that relation. Okay, so these are the type of questions. Please try to understand. This is the question from GATE 2023, right? So this is again a 2-mark question from GATE 2021. So please try to understand the quality of question that will be asked, right? So suppose the following functional dependencies holds on a relation U with attributes PQ RST. So you have a relation U with attributes PQ RST, and the FDs that holds are P implies QR, RS implies T. Now, which of the following functional dependencies can be inferred? So this is the property of closure. So I'll discuss all the type of questions related to concepts that we have discussed in the last class. So which of the following functional dependencies can be inferred? Inferred is basically the membership test from the above functional dependencies. So what can be inferred? Do you really think that it should be a question of 2 marks? So please try to understand. Sir, PS implies C. So what is PS closure? So what is PS? You know what? बहुत ज्यादा जिम कर लेते हैं ना, तो क्या होता है, पूरा बॉडी खिंच जाता है ना? So that's what happened with me. हाथ इससे ऊपर जा ही नहीं रहा है, तो जो 13 घंटे का लिखा है ना, पूरा एकदम खत्म हो गया है. So anyway, so sir, PS, now please try to understand which of the following functional dependencies can be inferred from the above functional dependency. हाँ, वो क्रैम्प हो रहे हैं, तो वो हाथ इससे ऊपर जाने में ऐसा लग रहा है कि क्या पाप कर रहा हूं मैं, है ना? So PS closer, R closer is T, P implies R, right? PS implies Q. Can you please check the question, because dependencies, is it an MSQ question? Which of the following functional dependencies can be inferred from the functional dependencies? It should be an MSQ question. It should be an MSQ question, right? So functional dependencies can be inferred from the above functional dependencies. So one is PS closure. Now please try to understand. Oh, damn tough. PS closure. Sir, PS closure with PS closure will be PS. And from P is the subset of PS. Therefore, you can include Q and R. Now, RS is present. So, RS is in the LHS. Therefore, yes, this can be inferred. R implies T. If you look for the R closure, sir, R closure will be R only पुष्पा बन गया हूं मैं, ऐसा हो गया हूं, पुष्पा. So it cannot be inferred. P implies R is obviously P closer will give you P, and because of P you can determine Q, R, nothing else. So P implies R can be inferred. PS closer will be P S. From P you can determine Q and R. Q and R. Now you have R and S in the relation, so you can determine T. Anyway, the only thing that is required is P. That is required is Q. So PS implies Q can also be inferred, right? झुकेगा नहीं साला, पूरा झुक गया है, ऐसा नहीं, झुक गया है ना. So the correct answer is A, C, D. Please don't laugh. अगर थोड़ा बहुत कहीं ऊपर नीचे दिखाई देता है तो please cooperate. Okay. So I hope you understand, sir. 2 marks question, sir. 2 marks question. So do you realize how easy is database management system from the relational model point of view? I'm not talking about SQL and relational algebra. Consider, so that's another dependency. So again, the similar type of question, so we are not going to spend too much amount of time. Consider the relation PQRSTUV with the following set of functional dependencies. PR implies ST is one FD and PSU implies QR is another FD. Which of the following is the trivial? Now, that's another. So there are 3 different types of functional dependencies: trivial, non-trivial, and semi-non-trivial. So which of the following is the trivial functional dependencies in F closure? Okay, so PR implies ST, is it trivial? No, sir. PR implies RT, is it trivial? No, sir. PS implies S is a trivial functional dependency. PSU implies Q. So it's a stupid question, right? Chale. So I hope you understand. Okay, so this is related to instance. This is related to instance, relational instance. Look at the question and give me the answer. Given an instance of students relation as shown below. So this is a student relation. This is the instance. For student name and student age to be a key. If you want that student name and student age becomes the key of this particular relation, right? The value of x should not be equals to what? So, sir, if you are saying that it should be a key, then all the values must be distinct. So they should have, the key attribute should have unique values. So the idea is, you must understand that student name and student age, Swati and 19 is perfectly fine. Swati is 18. So this is one value. So Swati 19 is different from Swati 18. So this is perfectly okay, no problem. Ganesh is a unique value, so you don't need to worry about that. So Shankar is there. So you should have the values of student name and student age together unique. So if it becomes 19, then Shankar 19, Shankar 19, there will be 2 tuples with the same value. Right? So if we make this 19, then there will be 2 tuples with the same value, and student name and student age will not be the key of the relation. So for distinct, so it should not be equals to 19. It should not be equals to 19. I hope you understand the type of question. Okay. So again, it's a GATE 22 question related to number of super key. Please give me the answer. Answer for this question. Fast. How do we determine the super key, number of super keys in a relation? First of all, we need to identify all the candidate keys of the relation. So, please tell me what are the candidate keys of this relation? Sir, A, B gives C, B, C gives D, and C gives E. So, do you realize that A, B is the only candidate key? A closer is A only, B closer is B only, A, B is the candidate key. Now, you know that no prime attribute is present in the RHS of any FD, therefore it will have only one candidate key, which is AB. Now, if AB is a candidate key, for remaining 3 attributes, you have 2 response 3 choices. For remaining 3 attributes, you have 2 response 3 choices, right? So, if AB is present, so both A and B must be present, and for remaining 3 attributes, you have 2 response 3 choices. Therefore, the number of super keys will be 8. Okay, come on. So, this is the question related to concept of minimal cover. Question related to concept of minimal cover. So, what did I say? The process of identifying the minimal cover may be difficult or may be time taking. The process of identifying the minimal cover of a given FD set may be time taking, and apart from that, given a question related to concept of minimal cover, please try to understand. Given a question related to concept of minimal cover, please don't start finding the minimal cover of the given FD set. Why? Because the minimal cover for a given FD set need not be unique. So perhaps the minimal cover that you identify is different from the minimal cover that is given in the option, right? So if at all a question related to minimal cover is asked, then always try to look for the correct option among the given options, right? So that's the idea. So we have V implies W, VW implies X, Y implies VX, and Y implies Z. So we just need to check that whatever, if this is your FD set F, then the minimal cover will be equals to this FD set. Minimal cover will be equal to this FD set. So V implies W is perfectly fine. Sir, V implies X. So look for the option. Sir, V implies W is perfectly fine. Here it is VW implies X and this is V implies X. So if V is present, you don't need W. If V is present, you don't need W. So this is also fine. Now, Y implies V. Sir, Y implies V and Y implies X. We have two things. Y implies V and Y implies X. So if Y implies V and V implies X is there, then you don't need X. So Y implies V and Y implies X. So if you have Y implies V and V implies X, then Y implies X is already present. Y implies X is already present. Y implies Z. Okay. So apart from this, nobody else gives Z. So this will also be required. Now, please try to understand. Please try to understand. Sir, the process may be very weird. So let's try to understand. Sir, here V closer is equals to VWX. That's it. V closer will be VWX. So here also V closer will be VWX. You can actually see V closer will be VWX. So that's another way of thinking, sir. Here VW closer will be VWX also. Here also VW closer will be VWX. Here Y closer is Y closer will be Y V, and V gives VWX and Y gives Z. So Y closer will be everything. So here also try to calculate. Y closer will be Y, V, Z, and V gives W and X as well. W and X as well. Okay. Now, sir, still we are not able to find that what are you actually trying to infer. So, look at all the FDs. So, first of all, sir, V implies W is present in this, V implies W is present in this, V implies W is present in this, V implies W is present in this as well. So, that's another way of looking at this. So, V implies W will be present in all the minimal covers. Then, V implies X is present, here V implies X is present, here W implies X is present, and here W implies X is present. So, what actually is happening? So, here from this VW implies X, there are two possibilities which are defined. One is V implies X, another is W implies X. So, it is trying to convey that when W is present, then this one is trying to convey that when W is present, V is not required, and it is trying to convey that when V is present, W is not required. So we very well understand that V implies W is already present. So if V is present, W will not be required. So B and D cannot be the right answer. B and D cannot be the right answer. So option elimination will work. So here V implies X is there, here also V implies X is there. Next one is Y implies V. So Y implies V is present in this as well as in this. So it's also fine. In this particular case, Y implies X is present. Here, Y implies X is not present. So these are the only two options. So let's check whether Y implies X is required or not. So you can understand that Y to V and V to X. Therefore, Y implies X will become redundant. Yes or no? So if at all the question is related to concept of minimal cover, try to solve that question by the options given in the question. We have already discussed the process of finding the minimal cover for a given FD set. But as I told you that minimal cover need not be unique. Therefore, you may find the correct answer, but still that answer that you have obtained may not be available in the option. So that's the only reason that I am saying that if at all the question is of minimal cover, please try to solve that question using the options. What are you saying, sir? कल आपने 10 hours class ली और आज फिर से मारे भाई मत पूछो. ठीक है? So the correct answer is answer A. So this is the question of minimal cover. Okay. This is the relation, this is the relation R, which has the FD set as given. Now it is asking, let's check the question, that these are the options, is a set of functional dependencies so that F closure is exactly the set of FDs that holds for R. Come on. So this statement is of no use. This statement is of no use if you try to understand. This is just there to create confusion in your mind. So it is just asking that what is the normal form of the relation. The question is actually related to normal form of the relation. So please give me the answer fast. Oh, again power cut. Just hope that nothing goes wrong. A. Okay. So the very first thing that you need to, sir, we have discussed 5 different cases. We have 5 different cases. So just recall them. Sir, proper subset of a candidate key implying non-prime attribute. This is one case. Proper subset of a candidate key plus non-prime attribute implying another non-prime attribute. One is non-prime attribute implying non-prime attribute. One is proper subset of candidate key implying proper subset of candidate key. Obviously, these are from different candidate keys. Proper subset of a candidate key plus non-prime attribute implying proper subset of candidate key. These are the 5 cases that we have discussed. So, to understand that what are the proper subset of candidate key and what are the non-prime attributes, the very first thing that you need to identify is the candidate key of that relation. So, first of all, sir, A is present in the RHS, B is present in the RHS, C is present in the RHS, D. So D is essential. E is present in the RHS. F is also present in the RHS. G is also present in the RHS. H is also present in the RHS. So we know that essential is D. D will be present in every candidate key. D will be present in every candidate key. Now, please try to understand D closure alone will be D only. So, if I add, let's check for other possibilities. If I can see that, sir, CHD, I don't know that what will happen, but please think that if I just try to add AD closure, sir, why are you adding AD? Because A gives BC, then B gives CFH, and F gives EG. So you can intuitively identify that A can produce most of the things, or otherwise. So we need a candidate key. So basically, if you look for the another approach which says that, sir, A, B, C, D, E, F, G, H closure is guaranteed to be A, B, C, D, E, F, G, H, right? So D is essential. Now please try to understand, if you can ensure F, then you can, let's assume that if I make sure that F will be present or F will be determined, then you can delete E and G. Now please try to understand, if you make sure that B is present, then you can remove C, F and H. So F can be removed, H can be removed, C can be removed. Now the only thing is, if you ensure A, then B can be determined. So if you know, if you have A, then B can be determined, so you can remove B if A is present. So do you realize that A and D together will be able to determine all attributes? So AD will be AD first of all, then A is the subset, therefore you can determine BC. Now B is the subset, therefore you can determine C, F, B is the subset, therefore you can determine C, which is already there. You can determine F and H. If you have F, you can determine E and G. Anything else is left? A, B, C, D, E, F, G, H. Everything is there. Now, D alone cannot determine all the attributes, and D is essential. Therefore, you don't need to check for A closure. So, AD is the candidate key. AD is one of the candidate key. Now, can we do some replacement? Who said AD is a candidate key? There are some other candidate keys as well. A can be replaced by E. Therefore, ED will also become a candidate key. Now, E can be replaced by F. Therefore, FD will also become a candidate key. Now, F can be replaced by B. Therefore, BD will also become a candidate key. B can again be replaced by A. Nothing else will be there. That's it. So these are the 4 candidate keys. These are the 4 candidate keys. Yes or no? These are the 4 candidate keys. You guys are saying only 2 candidate keys. I hope it's clear to everyone. Some people have said only AD is a candidate key or AD and ED is a candidate key, but there are other candidate keys. E can be replaced by F, therefore FD will also become a candidate key. F can be replaced by B, therefore BD will also become a candidate key. Now, no other possibility of replacement. G, no sir. C, no sir. F already replaced by B. If you replace B by A, then you will again get, so if you replace B by A, you will again get AD. No new FD will, no new candidate key will be there. Now, if these are the candidate keys, now please try to understand. Sir, CH, sir, both of them are non-prime attribute. Both of them are non-prime attribute. G is also a non-prime attribute. So this is A. Now, you can actually convert it into A implies B and A implies C. A implies B and A implies C. So what happens with respect to A implies B and A implies C? Sir, we know that non-prime attributes are, what are the non-prime attributes? Sir, A, B, C is one of non-prime attribute, D, E, F and G is another non-prime attribute. So C and G are non-prime attributes. Yes, H is also a non-prime attribute. H is also a non-prime attribute. So C, G and H are non-prime attributes. So C, H, G, all three are non-prime attributes. So here A is a non-prime attribute and sorry. What happened to me? Sir, A, so it's a proper subset of a candidate key and C is a non-prime attribute. So this is my type 1 FD. If type 1 FD exists, then the relation will be in 1NF but not in 2NF. Relation will be in 1NF but not in 2NF. So, do we need to check for others? So this is a proper subset of a candidate key. There is also a proper subset of a candidate key. So it's actually in 3NF but not in BCNF. What about this? A non-prime to non-prime, it is in 2NF but not in 3NF. What about this? Sir, B implies C will be in, so here we can again change B implies C, B implies F and B implies H, right? So B implies C is in 1NF because B is a proper subset of a candidate key and C is a non-prime attribute. B and F, so this is in 3NF. B and H, it is again in 1NF, right? So you can check that, you can check the normal form of all the FDs. This is also in 3NF because E is a proper subset of a candidate key. A is also a proper subset of candidate key. Now you can change F implies E and F implies G. So F and E both are proper subsets of candidate key. Therefore this is also in 3NF and F implies G is in 1NF, right? So all the FDs, so apart from the CH implies G which is in 2NF, all other FDs are either in 1NF or in 3NF. Any doubt in this? Damn easy question. Whenever a question comes related to normal form, just think of this 5 different cases. The only 2 things that are required are that you know how to calculate the candidate key of the given relation and you remember these 5 cases. Make sense? Okay, next one. This question is, please give me the answer, then I'll discuss. Because we did not discuss the normal forms in detail, therefore I have included this question. You must understand that, sir, the 5 cases that I have discussed are proper subset of a candidate key giving non-prime attribute, proper subset of a candidate key plus non-prime attribute giving non-prime attribute, non-prime attribute giving non-prime attribute, proper subset of a candidate key giving another proper subset of candidate key, proper subset of a candidate key plus non-prime attribute giving proper subset of another candidate key. Now my question is, if all attributes, please, why this question is being discussed, if all attributes are prime attribute, then first 3 cases are not allowed. If all attributes are prime attributes, then first 3 cases will not be allowed, right? So if all attributes are prime attribute, relation will be at least in 3NF. Just remember this point that we did not discuss in the last class. If all attributes are prime attributes, relation will be at least in 3NF. Apart from that, sir, proper subset of a candidate key is possible only if the candidate key is a composite candidate key. If all the candidate keys are simple candidate keys, my question is, if all the candidate keys are simple candidate keys, then can we have proper subset of a candidate key? No, sir. Proper subset of a candidate key will not exist if all the candidate keys are simple candidate keys. So, if all the candidate keys are simple candidate keys, then first case will not be possible, but third case is still possible. So, because first case is not possible, therefore relation will be at least in 2NF, but relation need not be in 3NF because the third type of FD is still possible, right? Okay. What else, sir? If all the attributes, please try to understand. If all the attributes are prime attributes, if all the attributes are prime attributes and all the candidate keys are simple candidate keys. So all the attributes are prime attributes, therefore first three cases are not possible, and all the candidate keys are simple candidate keys, then these two cases are also not possible. So if all the attributes are prime attributes and all the candidate keys are simple candidate keys, then none of the five cases are possible, therefore relation will be in BCNF. Clear these statements? If all the attributes are prime attributes, first three FDs are not possible, relation is at least in 3NF. If all the attributes are prime attributes and all the candidate keys are simple candidate keys, then the relation is in BCNF. If all candidate keys are simple candidate keys, then type 1 is not possible, but type 3 is possible, therefore relation will be at least in 2NF, but may or may not be in 3NF. Relation will be at least in 2NF, but may or may not be in 3NF. Okay, now one more type of note that you can write is that, sir, every table with two single valued attributes. So it has been asked multiple times in different way. So a relation with two attributes is called a binary relation. A relation with two attributes is called a binary relation. सर एक बार सिंपल कैंडिडेट की बता दो. अरे सिंपल कैंडिडेट की जो एक सिंगल एट्रीब्यूट से मिलके बनती है बच्चा, कैंडिडेट की व्रज, ऐसा रिवीजन करोगे then it will be very dangerous. A candidate key which is formed of a single attribute is called a simple candidate key, right? Now if we have a relation which is a binary relation, 1NF, 2NF, 3NF and BCNF, correct or not? Please try to understand. A relation with two attributes can have only four different types of FD sets. Sir, what are they? Sir, one type of FD set will be A implies B will be present, but B will implies A will not be present. Another FD set is B implies A will be present, but A implies B will not be present. Another will be A implies B is present as well as B implies A is present. Another will be no FD set is present. No FD, neither A determines B nor B determines A, right? Now please try to understand, if this is the case, then candidate key will be A in this case candidate key will be B, in this case candidate key will be A as well as B, in this case candidate key will be AB. Please try to understand another note that you must understand. If there's a relation with no non-trivial FD. If there is a relation with no non-trivial FD, then it will always be in BCNF. A relation with no non-trivial FD is always in BCNF. Sir, reason? Sir, if there exists a non-trivial FD, X implies Y, in which X is not a super key. If there exists a non-trivial FD, X implies Y, in which X is not a super key, then only it will cause redundancy in the relation. If there is no non-trivial FD, then there will be no redundancy because of functional dependency. If there is no redundancy because of functional dependency, then relation will be in BCNF. So, sir, this is in BCNF. Both are candidate key. So, this is a super key. This is a super key. Both of them are in BCNF. Right? Here, sir, candidate key is B, therefore BCNF. Sir, candidate key is A, so it's a super key, therefore it is also in BCNF. So, if there is a relation that contains only two attributes, then no matter what type of functional dependency exists in that relation, it will always be in BCNF. Now, if I are saying that relation is always in BCNF, then a relation which is in BCNF will be in 3NF, will be in 2NF, will be in 1NF as well. So, can we say that every table with two single value attribute is in 1NF, 2NF, 3NF and BCNF? Yes, sir, statement 1 is true. Now, another statement which is being asked, so the reason for having this question was just to explain this particular concept. Otherwise, second statement is related to minimal cover only. AB implies C, D implies E, E implies C is a minimal cover of the set of functional dependencies. Let's check whether it is a minimal cover or not. So, AB implies C is present as it is. D implies E is present as it is. Now it is saying that only E implies C is required, AB implies E is not required. So please try to understand, if you try to calculate AB closure without AB implies E, then what will be AB closure without AB implies E? Sir, AB closure will be A, B, from this you will get C, from this you will get C. Now my question is that will you be able to determine E from AB if this AB implies E is not present? That's my question. Sir, will you be able to determine AB implies E? Will you be able to determine E from AB if AB implies E is not present? So, something is not right. What happened? All good, all good. So, the closure of AB without AB implies E, the closure of AB without AB implies E will be ABC. It does not determine E. So, AB implies E is not redundant. AB implies E is not redundant. So, if it is not redundant, then you cannot remove this. If it is not redundant, then you cannot remove this. So, statement S2 is false. So, S1 is true and S2 is false. Correct statement will be answer A. Clear? Clear? Okay, sir. Next question. Ocha, this is just for the explanation purpose. So, this is related to concept of lossless joint decomposition or lossy decomposition. Please give me the answer fast. We have discussed all these concepts in the last class. There is no question which cannot be solved based on the discussion that we had yesterday. There is no question which you will not be able to solve. And all the questions will be of this type only. So, if you have a relation R with attributes P, Q, R, S, T, X, Y, W, Z with the following functional dependencies: PQ implies X, P implies YX, Q implies Y, and Y implies ZW. So, these are the FDs that exist in the relation. Consider the decomposition of the relation R into constituent relations according to the following two decomposition scheme. So, one is D1, R is decomposed into three relations. One is PQST, another is PTX, another is QY, another is YZW. Decomposition D2 is PQS, TX, QY, and YWZ. Now, we need to check which of the following decomposition is lossless joint decomposition. So, please try to understand. Sir, if we try to look at this two, then P and T is the common attribute. If you have PT, then P can determine X. So, this two can be joined. This two can be joined. After join, you will have PQSTX, PQSTX. Now, you have Q common among these two. You have Q common among these two, and Q closure will contain Y. Therefore, Q will be the super Q of this. So, after join, you will have PQSTXY. You will have PQSTXY. Now, after this, sir, you will have Y in common, and Y closure determines ZW. So, Y will be the super Q of this relation. So, you know that this is lossless. You know this is lossless. In the same order you can join. You can join PQST with PTX, then the join of this two can be joined with QY, then the join of this three can be joined with YWZ. Make sense? Make sense? Is it clear that D1 is lossless? Is it clear that D1 is lossless? Now, let's think of this other one. Sir, PQS and TX. Sir, these two cannot be joined. Now, let's try to join this two. Sir, Q is the common attribute and Q is the super key. Then you know that you will be able to join this two and you will have PQXY. You will have PQXY. Now, the beauty of this question is, that there's a relation, there's a subrelation with TX. So, there is a subrelation Tx. So, do you realize that no other relation has T? No other relation contains attribute T. So, T can never be in common. At most, T cannot be in common and X cannot be in common. So, you must understand that T and X, what are the attributes which are not common. Even if we join this tree, that is, even if you join PQS, QY and YWZ, they can be joined. So PQSY can again be joined with YWZ because Y is the common attribute and Y is the key of this YZW. Therefore, you will ultimately have PQSY. You will ultimately have PQSY ZW. But you must understand that T and X are exclusive. T and X are exclusive to this particular subrelation. So neither T is common with any other subrelation nor X is common with any other subrelation. So whenever you try to join this TX with any combination, then the intersection will be phi. And I told you that whenever intersection is phi, the join will always be lossless. So because of this TX, the join will be lossy. Sorry, when there is no common attribute, join will always be lossy. So decomposition D1 is lossless, but decomposition D2 is lossy. So D1 is a lossless decomposition, but D2 is a lossy decomposition. So option A is the correct answer. Any doubt in this? Any doubt? Fast. We need to finish relational model as soon as possible so that we can spare some time on the concept of relational algebra and SQL. Okay, sir. This is another question related to decomposition. We did not solve the questions of decomposition in the last class, lossless joint decomposition and dependency preserving decomposition. Therefore, I have taken 3-4 questions from that particular topic. Now tell me. Okay, sir. We have a relation X with attributes PQRS, and these are the FDs over that relation X. X is not in BCNF. They are saying X is not in BCNF. Even if they don't say that X is not in BCNF, we can determine that X is not in BCNF because of based on this particular FD. Now, suppose X is decomposed into two schemas Y and Z. Now, you have decomposed this X. So, X is a relation with attributes PQRS. Please try to understand. You have decomposed it into two subrelations Y that contains only two attributes PR and Z that contains three attributes QRS. Right? Now, what is being asked? Consider the two statements about this decomposition. Both Y and Z are in BCNF. So, what did I say? Sir, to check the normal form of this subrelation Y and to check the normal form of this subrelation Z, we must have the functional dependencies that holds in this subrelation Y and the functional dependencies that holds in this subrelation Z. So, if you try to understand this, sir, what will be P closure? Sir, P closure will be P only, but R closure will contain P. So, do you realize that R implies P will be present in this? R implies P will be present in this subrelation Y. So, the only FD that will hold in this subrelation Y will be R implies P and candidate key will be R. Candidate key will be R. Therefore, Y is in BCNF. Y is in BCNF. This is clear. Now, let's think in terms of Z. Sir, Q closure will be, sir, Q closure, please check, Q closure will be Q only. Sir, R closure will be RP. R closure will be RP. Do we have P in this relation? No, sir, we don't have P in this relation. Sir, S closure will be SQ. So, you will have S implies Q. S closure will be SQ. Therefore, you will have S implies Q. What else? Sir, QR closure will contain S. Therefore, QR implies S. QS. Sir, QS closure will not contain anything. Sir, RS closure. Yes, RS closure will contain Q. Okay, so these are the only three FDs that holds in this relation. These are the only three FDs that will hold in this relation, yes or no? These are the only three FDs that will hold in this particular relation. So, do you realize that R is the essential attribute? R is the essential attribute and R is not the key of this relation. R is the essential attribute because R is not present in the RHS of any FD. R is not present in the RHS of any FD. So R is the essential attribute. Therefore, candidate key will be R alone cannot become the key. So with R, you can add Q or you can replace Q by S. So you will have RS. So these are the two candidate keys. RQ and RS are the two candidate keys. Now, sir, Q is a proper subset of a candidate key. Please. So this Q is a proper subset of a candidate key. This S is also a proper subset of a candidate key. Therefore, it is in 3NF but not in BCNF. It is in 3NF but not in BCNF. But the statement says that both Y and Z are in BCNF. This is false. The statement says that both Y and Z are in BCNF. This statement is false. Now it says decomposition of X into Y and Z is dependency preserving decomposition and lossless. Please try to understand. Please try to check all the FDs are preserved or not. Sir, R implies P is preserved in F1. Let's call it F1 and let's call it F2. Right? So R implies P is preserved in F1. Sir, QR implies S is also preserved and S implies Q is also preserved. So yes, it is dependency preserving. Yes, it is dependency preserving. What about lossless? So the common attribute among these two is R and R is the super key. Common attribute among PR and QRS is R and R is the super key of this relation Y. Therefore, it is lossless as well. So decomposition of X into Y and Z is dependency preserving and lossless, but it is not in BCNF. But it is not in BCNF. So statement 2 is true, statement 1 is false, 2 only is the true statement. Clear? Second, the only statement which is true is second statement, first statement is false. Okay, sir, this is a different type of question. Sometimes they may not give you the functional dependencies directly. Sometimes they may not give you, sir, RS implies Q एक बार बता दो. Sir, RS implies Q एक बार बता दो. बेटा सुनो यहाँ पर, जहां पर जो FDs हैं, अगर मैं यहां पर RS का सर कैसे निकालता हूं, कौन है ये? मिनोताकू, पता नहीं कैसा खतरनाक नाम रखते हो यार आप लोग. मैंने क्या बोला था सर, किसी भी सब रिलेशन का एफडी सेट निकालने के लिए उसके नॉन एम्प्टी प्रॉपर सबसेट्स का क्लोजर निकालना होता है. क्यू क्लोजर निकालता, आर क्लोजर निकालता, एस क्लोजर निकालता, क्यू आर क्लोजर निकालता, क्यू एस क्लोजर निकालता एंड आर एस क्लोजर निकालता. सो अगर आप आर एस नहीं समझ पा रहे हो तो आर एस क्लोजर निकालो सर. यहां से सर आर एस क्लोजर में क्या आता सर, जब मैं आर एस क्लोजर निकालता तो आर आता, एस आता, और आपको पता है एस क्यू को डिटरमाइन कर सकता है इसलिए क्यू भी आता, एस क्यू को डिटरमाइन कर सकता है इसलिए क्यू भी आता, और आर पी को डिटरमाइन कर सकता है इसलिए पी भी आता. बट पी इज नॉट इन द रिलेशन तो इसको हटा दो. आर एस से आप क्यू डिटरमाइन कर सकते हो, आर एस से आप क्यू डिटरमाइन कर सकते हो. क्लियर सर? क्यू क्लोजर में सो दिस इज हाउ आर एस इंप्लाइज क्यू इज डिटरमाइंड. अगर आप किसी भी सब रिलेशन का एफडी सेट निकालना चाहते हो तो उसके जितने भी नॉन एम्प्टी प्रॉपर सबसेट्स हैं सबका क्लोजर निकालना होता है. मेक सेंस? सो आर एस इंप्लाइज क्यू विल आल्सो होल्ड इन दिस रिलेशन. चाहे वो आपको यहां से सीधे सीधे दिखाई नहीं दे रही है, लेकिन ओरिजिनल एफडी सेट में आर एस इंप्लाइज क्यू था, लेकिन उसको लिखने की जरूरत नहीं पड़ी क्योंकि वो इन एफडी से इंप्लाय होता था. ठीक है, चले. What about this? So, as I said, sometimes they may not give you the direct functional dependencies, but they can provide you the property of the individual attributes, and based on that, you will have to identify the functional dependency of that particular relation. So, consider a relational table with a single record for each registered student with the following attributes. So, let's look at the equation very carefully. That single record for each registered student. So for every registered student, there will be a unique record. For every registered student, there will be a unique record. Clear? So if you have anything which can identify the student, then that particular attribute will become the key of this relation. Make sense? So, sir, registration number will be unique to every student. Registration number will be unique to every student, that we can understand. इसने बोला भी है unique registration number of each registered student. So can you say that registration number will be a key? Can you say that registration number will be a key? Can you say that registration number, sir, registration number can identify each record uniquely, because registration number will be unique for every student, and there will be exactly one record for every student. Therefore, it will be a key. Clear? Okay. Now it says that look at the concept carefully. It says registration number can be primary key. Registration number can be primary key. Now, please try to understand, is it possible that there is a student in the university and he does not have a registration number? Is it possible that there is a student in a college or university and he does not, or he or she does not have a registration number? No, sir, it is not possible. Therefore, it is a key, and registration number will never have a null value. Registration number will never have a null value. So, key, and this will be non-null. So, a key which is non-null, therefore, it can become a primary key. Yes or no? Sir, हम primary key, we can define a key as a primary key only if its attributes are not allowed to take the null values. Yes or no? Sir, this statement is correct. As far as I can see, this statement is correct. Another, sir, UID. UID, sir, unique identity number. Unique identity number. So it will be unique to every student. Unique identity number, it will be unique to every student. So unique at the national level for each citizen. Unique at the national level for each citizen. So I want to ask, is it necessary for UID to be unique for every student? Please, 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 is it necessary for UID to be unique for every student? No, sir. Generally, UID need not be unique, because you are saying that UID will be unique at national level for each citizen. But two different countries may have or may follow the same pattern to define the unique identity number. So on country level, two different students may have the on country level, two different students may have the same UID, may have the same UID. Make sense? So that's what you need to understand. And in our college, it is not necessary. Nowhere the question is saying that all these students are from the same country. Nowhere the question itself is saying that all these students are from the same country. Therefore, students may be from different country and they may have same. The students may be from different country and they may have same UID, right? So UID is unique at the country level. That's what you need to understand. Now, another thing is bank account number. Bank account number. Please try to understand. Unique account number at the bank. Sir, you will have unique account number at the bank. But at the bank level, every account number will be unique. But a student may have different accounts in the different bank. Yes or no? So a student can have multiple accounts or joint account. This attribute stores the primary account number. So, okay, what is given in the question? Sir, a student may have multiple account. A student may have multiple account. Please try to understand. A student may have multiple account, but this bank account number attribute will only store the primary account number. Will only store the primary account number. Clear? So that's the idea. Please try to understand that bank account number may be multiple for a student. So because you are storing, because you have only one record, per student, because you have only one record per student. So if S1 has two account numbers, account number 1 and account number 2, then to convert this multi-valued attribute into single valued attribute, you will have to define two tuples. S1 has account number A1 and S1 has account number A2. So if you are storing all the accounts of a student, then either you will have multi-valued attributes which is not allowed in a relation, so you will have to create separate tuples, and we are having a unique tuple corresponding to each student. Therefore, for every student, you will store only one account number. And that account number will be primary account number. The question as such is not important, but please try to understand such type of question may be asked in the exam, and these are the questions which will create confusion in the mind of students. Clear? So that's what you must understand, that a student may have multiple accounts, But can we store multiple account in a single row? Can we store information of multiple account in a single row? No, sir. If we store information of multiple account in a single row, that bank account number attribute will become a multi-valued attribute, and it is not allowed in a relational table. It is not allowed in a relational table. Just remind the statement that our relation is at least in 1NF. By default, normal form of relation is 1NF. That is, you cannot have multi-valued attribute in a relational table. Clear? So you are storing only primary account number. You are storing only primary account number. Now my question is, sir, a student can have multiple accounts or joint account. So may it be possible that two students have same primary account? Is it possible that two students have same primary account? Please think. Is it possible that two students have same primary account? Please answer. Yes, two different students may have same primary account. Why no? Nikhil, they may be brother. And both of them, there may be two students जिनके पप्पा सेम हैं एंड उनका जो प्राइमरी उनका जॉइंट अकाउंट उनके फादर के साथ है, तो दोनों का अगर एक ही अकाउंट है, राइट? So you must understand that both the students or both the siblings will have same primary account number. So that's the thing that you must realize based on these statements. Now another is name of the student. Sir, this is definitely not unique. By default, if nothing is given, then name is by default not unique. Hostel room number of the hostel. So sir, the room numbers may have double occupancy. The hostel rooms may have double occupancy. So, did not say anything that only one student lives in a brother हुआ तो हो सकता है same. Yes, that's what I'm saying. So, who said that two brother cannot be registered in the same college? They can be, right? So these are the small things that you must understand. Now it is asking which of the following is incorrect. What is being asked is which of the following is incorrect. So registration number can be primary key. This is correct. Bank account number is a candidate key. Please tell me, क्या बैंक अकाउंट नंबर कैंडिडेट की हो सकता है? That's what I want to know. क्या बैंक अकाउंट नंबर प्राइमरी की हो सकता है? सर, बैंक अकाउंट नंबर प्राइमरी की हो ये जरूरी नहीं है, बिकॉज दो स्टूडेंट्स का प्राइमरी अकाउंट नंबर सेम हो सकता है. सो दिस स्टेटमेंट बिकम्स इनकरेक्ट. विल थिंक अबाउट अदर स्टेटमेंट्स एज वेल. Right? Sir, UID is a candidate key if all students are from same country. Yes. What did I say? Sir, UID may be same if the students are allowed from different countries. But if you are allowing the students from a same country, then all of them will have distinct UIDs. And this statement will become correct. Now my question is, can it be a primary key? Again, can it be a primary key? Is it necessary for every student to have a Aadhaar number? Think. Can it be a primary key? No, sir. It is not necessary for every student to have a Aadhaar number. I hope you understand. It is not necessary for every student or every person in the India to have an Aadhaar number or something like that, right? So it may be a candidate key. So it is UID is a candidate key is fine, because candidate key attributes may take null values. Candidate key attributes may take null values, but primary key attributes cannot take null values. सिंपल क्वेश्चन को गेट वालों ने, हाँ जी मैं वही कह रहा हूं, इसीलिए मैं आपसे कहने की कोशिश कर रहा हूं कि अगर इस टाइप के क्वेश्चंस आते हैं तो आप सोचो कि आप क्या क्या सोच सकते हो. एंड दैट्स द रीजन आई हैव टेकन दिस क्वेश्चन. अदरवाइज देयर वाज नो नीड टू इंक्लूड दिस क्वेश्चन इन दिस पर्टिकुलर सेशन. बट if FDs are not given, then based on the attribute, what did I tell you in the last class, that either functional dependencies will be given, or based on the properties that can be specified by the name of the attribute, you can identify that what type of dependencies will hold in a relation, right? So if the names of attributes, sir, if ABCD is given, you don't know what is A, what is B, what is C, what is D. So they will have to specify the functional dependencies. But if attribute names are given, then based on the properties specified by that attribute name, you may determine that what type of functional dependencies will hold in that relation. हाँ जी, 1 मार्क का है, क्या करें, होता है ऐसा. Okay, so if S is a super key such that, now look at this, if S is a super key, there's an attribute S, whatever, if S is a super key such that S intersection UID is null. Look at this carefully. S is a super key, some attribute S is a super key such that if you intersect S with UID, it is null. That means there is nothing in common, there is no values in common of S and UID, then S union UID is also a super key. Yes or no? Yes or no? Yes, sir. So there are no two values of S and UID which are in common. Therefore, S union UID will also not have any value in common. Therefore, it will also be a super key. Therefore, it will also be a super key. So this statement is also correct. So the only incorrect statement is this statement A, and the whole concept of this particular question was related to this joint account, because two students may have same primary joint account. So a single statement in the equation can change the answer. Otherwise, you will be like, sir, bank account number will be unique to every student. Clear? So the correct answer is answer A. Okay, so we are done with the questions of relational model. Please tell me, do you think that there is a specific type of question with which you are struggling and I did not cover? Is there any question or any specific type of question in the relational model and normal forms with which you are struggling and I did not cover? व्रज भैया, मैं कह रहा हूं, आप हो, आपका एक भाई है ना, आप हो, आपका एक भाई है, आपका अपना कोई अकाउंट नंबर नहीं है, आपका अपना कोई अकाउंट नंबर नहीं है, आपका और आपके भाई का एक कॉमन जॉइंट अकाउंट है, आपका और आपके भाई का एक कॉमन जॉइंट अकाउंट है. व्रज सुनो ढंग से, व्रज सुनो, आपका और आपके भाई का एक कॉमन जॉइंट अकाउंट है, आपका कोई पर्सनल अकाउंट नहीं बनाया पप्पा ने. ठीक है, तो अगर आपका और आपके भाई का एक कॉमन जॉइंट अकाउंट है और हमको प्राइमरी अकाउंट स्टोर करना है हर स्टूडेंट का, तो आप अपने प्राइमरी अकाउंट नंबर में भी वही अकाउंट नंबर डालोगे और आपका भाई भी अपने अकाउंट नंबर में वही अकाउंट नंबर डालेगा, क्योंकि आप दोनों के पास एक ही अकाउंट नंबर है. हाँ या ना? आप दोनों के पास सिर्फ एक ही अकाउंट नंबर है और आप दोनों का सिर्फ एक ही अकाउंट नंबर है, तो वही प्राइमरी भी है. एक से ज्यादा होते तो आप चूज करते, एक से ज्यादा अकाउंट होते आपके पास तो आप चूज करते कि आपका कौन सा प्राइमरी है, बट आप दोनों के पास एक ही अकाउंट है. राइट, आपके पास भी आपका और आपके भाई का सिर्फ एक ही अकाउंट है और वो आप दोनों का जॉइंट अकाउंट है, तो आप भी अपने प्राइमरी अकाउंट नंबर में वही अकाउंट बैंक अकाउंट डालोगे, और है ना, अब दोनों सेम डालोगे. अब अगर दोनों सेम डालोगे, अगर दोनों सेम डालोगे तो दो टपल हो गए जिनके अंदर बैंक अकाउंट नंबर की वैल्यू सेम है. अगर दोनों सेम डालोगे तो आपके रिलेशन में दो टपल हो गए जिनमें बैंक अकाउंट नंबर वैल्यू सेम है. अगर दो टपल में किसी एट्रीब्यूट की वैल्यू सेम हो तो क्या वो की बन सकता है? अगर दो टपल में एट्रीब्यूट की वैल्यू सेम हो तो क्या वो की बन सकता है? सिंपल क्वेश्चन. हाँ सर, बट यूआईडी इज अ कैंडिडेट की. Sir, but UID is a candidate key, then on intersection with super key. नो नहीं बन सकता, तो नहीं बन सकता, तो इसीलिए तो वो इनकरेक्ट है, इसीलिए तो वो इनकरेक्ट है. दी तेजा और निखिल, आप दोनों लास्ट वाले में स्ट्रगल कर रहे हो. अब बात समझने की कोशिश करना. सर, इफ एस इज अ सुपर की, मैं आपसे ये बोल रहा हूं एस एक एट्रीब्यूट है, देख लो यहां पर. समझते नहीं हो यार। कोई भी एक एट्रीब्यूट है और ये एक सुपर की है, इसका मतलब इसके अंदर सारी की सारी वैल्यूज यूनिक होंगी। एस एक सुपर की है और इसके अंदर एस ऑलरेडी एक सुपर की है। सुनो मेरी बात, हाँ जी, सिंपल ही निकलता है, आप जबरदस्ती उसको टिपिकल बना देते हो। सर एस एक ऑलरेडी सुपर की है, तो क्या मैं ये बोल सकता हूं कि एस की सारी ऑल दी वैल्यूज ऑफ एस आर यूनिक? वी आर सेइंग दैट इफ एस इज अ सुपर की, if S is a super key, if S is a super key, so do you realize that all the values of S are unique? Itna clear? All the values of S are unique. There may be some values that are null. There may be some values that are null. है ना? दूसरा आपसे ये बोल रहा है, सुनो अच्छे से, कोई कंफ्यूजन नहीं है, यहां पर फालतू की बात कर रहे हो। अगर मैं बोल रहा हूं कि सर एस एक सुपर की है, तो किसी भी सुपर सेट का अगर कोई भी सुपर सेट लोगे, फॉरगेट अबाउट दिस थिंग, आप इससे सिर्फ जस्ट कंफ्यूज हो रहे हो। मैं आपसे क्या बोल रहा हूं, सर अगर एस एक सुपर की है तो क्या उसका कोई भी सुपर सेट भी यूनिक वैल्यू ही कंटेन करेगा? अगर एस एक सुपर की है तो क्या एस का कोई सुपर सेट भी हमेशा यूनिक वैल्यू ही कंटेन करेगा, हाँ या नहीं? Forget about this S intersection UID is null. Forget about this statement that S intersection UID is null. Sometimes these statements are just to create confusion, and this question is quite confusing. I mean, this question is designed to confuse students. No other reason. It's a damn easy question, but so many statements, they just want to check your uh, reading comprehension, nothing more than that. So the idea is, if S is a super key, then the values of S are already unique. If you have any superset of S, so if you union S with UID, if you union S with UID, that means if you combine these two attributes, if you combine these two attributes S and UID, if you combine these two attributes S and UID, then can you say that it will also have unique values? Right, Teja and Nikhil? So if S is unique, the values of S union UID will also be unique. If S has unique values, the values of S union UID will also be unique. So it will be a super key. What is so confusing? Huh? This S intersection UID is null is just to create confusion. So that's what I'm trying to suggest, that sometimes questions are asked just to trouble you, but they have nothing really. सर MCQ ही था ना भाई, चल मारो। अच्छा जी, ऐसे नहीं, चिल नहीं मारना होता है। अगर आप में उसमें कुछ ऐसा होता जो काम का था तो मैं डेफिनेटली एक्सप्लेन करता। चले, सो आई बिलीव रिलेशनल मॉडल एंड नॉर्मल फॉर्म का हर क्वेश्चन आप लोग गेट में सॉल्व करके आओगे, इसके अंदर कोई कॉम्प्रोमाइज नहीं होना चाहिए, है ना? नाउ लेट्स स्टार्ट विद द concept of relational algebra. What did I say? So the most important concept of relational algebra is the concept of division. So give me the answer of this question. Sir 2021 set to 1 mark question ही नहीं समझ आ रहा है। बेटा क्वेश्चन थोड़ा सा मनीष 2-4 स्टेटमेंट बोल दो तो मैं गूगल कर लेता हूं, तो मुझे समझ में आ जाए कौन सा क्वेश्चन है, ऐसा रटे हुए थोड़ी ना है। मनीष थोड़ा सा तो आइडिया दो कि क्वेश्चन है क्या। आप लोग इसका आंसर दो तब तक। So consider the following 3 relations in a relational database. One is employee relation, which has employee ID and the name of that employee. Another is brand, इसका मतलब ब्रांड की आईडी और ब्रांड का नाम, ठीक है। और दूसरा है ऑन, कि कौन सा एम्प्लॉई कौन सा ब्रांड ऑन करता है, कौन सा एम्प्लॉई कौन सा ब्रांड ऑन करता है, ठीक है। चलिए, ये है कहानी। नाउ विच ऑफ द फॉलोइंग रिलेशनल अलजेब्रा एक्सप्रेशन रिटर्न द सेट ऑफ EIDs, रिटर्न द सेट ऑफ EIDs हु ऑन ऑल ब्रांड्स। अब कल वाले उस पे जाओ, जब भी मैंने बोला था कि कभी भी अगर ऑल एंड एवरी की बात होगी यू विल थिंक इन टर्म्स ऑफ डिवीजन, कभी भी अगर ऑल और एवरी की बात होगी यू विल थिंक इन टर्म्स ऑफ डिवीजन. So you need the relational algebra expression that returns the set of EIDs who on all brands. So which employee owns which brand, that information is available in the on table. So please try to understand. Sir, do I really need to project EID and BID? Recall the statement from the last class that do I really need to project this EID and BID from the on table? No sir, because these are the only two attributes in the on table. These are the only two attributes. EID and BID are the only two attributes in the on table. So even if you do not specify this EID and BID, it will be perfectly fine, right? But it's good to have this. So please try to understand. We need EID and BID such that these BIDs are, so these are the EIDs such that they are associated with all the BIDs of brand table. They are associated with all the BIDs of brand table. So the concept is very simple, that you just need to define that project EID and BID from on and divided by from BID of brand, right? So this will give you the EIDs of employee who on all brands. Clear? So sir, सबसे पहले तो this is what you will have. So anyway, this will already give you the EIDs. This will already give you the EIDs. This will already give you the EIDs of the employee who on all brands. If you further project EID from the EID, will there be any difference? There is a tuple, there is a table that contains EID column only. Now, from that table, if you project EID, you will get the same thing, nothing else, right? So, sir, this statement A is guaranteed to produce the correct answer. Okay. Apart from that, do we have any other answer which is correct? Sir, the other answer here is related to the derivation of division operation. So if you want to define this, what will happen? Let's assume that all EID on all brand. Let's assume all EIDs of on table on all brands, right? So all the EIDs will all on brands. Then from that we will subtract that actually who on which particular brand. So after the subtraction, you will get the EIDs of the employee who do not own all brands along with the brand IDs not owned by them. Clear? So this is the idea. From that, if you project the EID, you will get the EIDs of the employee who do not own all brands. If you subtract those EIDs from all the EIDs of the on table, then you will be left with only those EIDs which are associated with all the brands. So please try to understand. First of all, these are the EIDs from the on table. These are the BIDs from the brand table. So if you perform this cross product, every employee on all brands. So from that subtract the actual owner information. So you have subtracted the actual owner information. So you will have the tuples in which you will have the EIDs of the employee who do not own all brands along with the brand IDs not owned by them. So if you project the EIDs, then you will get the EIDs of the employee who do not own all brands, and these are all the EIDs in the on table. So from all the EIDs, if you subtract the EIDs of the employee who do not own all brands, then you will be left with the EIDs of the employee who own all brands. Clear? So B is also true. So what about this? Sir, what actually will be produced by this particular? What actually will be produced by this particular? Will it give the correct answer? Sir, it will give me the EIDs from the on table which are associated with all the BIDs present in the on table. It will give me the EIDs of the employee from the on table which is associated with all the BIDs present in the on table. But it does not mean that on table contains all the BIDs of branch or brand. The on table need not include all the BIDs of the brand. My question is, if somehow it is given in the equation, that all the brands are owned by some of the employee. If I ask you one simple thing, that if all the brands are employed, or because if I say if all the brands are owned by at least one employee, then this option C will also produce the same answer. This answer C will also produce the same answer. Will there be any difference? The answer C will produce the same answer as option A if somehow it is given in the question that all the brands are owned by at least one employee. Because if all the brands are owned by at least one employee, then all the BIDs will be present here. All the BIDs of the brand table will be present in the on table as well. Yes or no? Yes or no? But it is not given in the equation. But if I make some modifications in the equation, option C also may be true. Now, so the last one is, so what does it do? Please try to understand. It is saying that take EIDs from the on table and take BIDs from the on table and perform the cross product. So basically, this is not we are looking for. This will create a weird answer. This will create a weird answer. So what will be the result of this option D? What output will be produced by this option D? See, that's the important thing. When you are trying to solve a question, don't only look for the right options. When you are trying to solve a question, don't only look for the right options. Please try to check that what exactly will be produced by this option D. Can anybody tell me that what exactly will be produced by option D? There will be only two scenarios. There will be only two scenarios. Please tell me that what output will be produced by option D. नितेश, बी वाला ऑप्शन इसलिए समझ में नहीं आया क्योंकि आपने कल वाली क्लास अटेंड नहीं की है ना. नितेश, बी वाला ऑप्शन इसलिए समझ में नहीं आया क्योंकि आपने कल वाली क्लास अटेंड नहीं की. तो जिनको बाकी सारे लोग मुझे ये बताओ कि ऑप्शन डी क्या प्रोड्यूस करेगा. देयर आर टू स्पेसिफिक सिचुएशंस. मुझे बताओ कि कौन सी दो सिचुएशंस पॉसिबल हैं और उन सिचुएशन में ऑप्शन डी क्या प्रोड्यूस करेगा. टेल मी. बेटा अगर विजय बैच से अटेंड की थी तो मैंने वहां पर आपको प्रॉपरली डिवीजन का डेरिवेशन समझाया है. रिट्रीव एसआईडीज ऑफ द स्टूडेंट्स हु एनरोल्ड फॉर ऑल कोर्सेज. ट्राई टू रिकॉल दैट कॉन्सेप्ट. अरे ईआईडी तो प्रोड्यूस करेगा भाई, लेकिन कौन सी ईआईडीज प्रोड्यूस करेगा. देखो यहां पर दो सिचुएशन है. यहां पर दो सिचुएशन है. अगर सुनना अच्छे से, अगर ऑन टेबल में ब्रांड टेबल की सारी बीआईडीज प्रेजेंट हैं तो ऑप्शन डी क्या प्रोड्यूस करेगा. और अगर एक भी ऐसी ब्रांड है ब्रांड टेबल में विच इज नॉट प्रेजेंट इन दी ऑन टेबल तो ऑप्शन डी क्या प्रोड्यूस करेगा. सुनना सर, दो सिनेरियो है. अगर आपके ब्रांड टेबल की सारी बीआईडीज ऑन टेबल में प्रेजेंट है, अगर आपके ब्रांड टेबल की सारी बीआईडीज ऑन टेबल में प्रेजेंट है, देन जब आप ये क्रॉस प्रोडक्ट परफॉर्म करोगे तो इस क्रॉस प्रोडक्ट का रिजल्ट होगा जहां पर हर एम्प्लॉय हर ब्रांड को ऑन करता है. हर एम्प्लॉय हर ब्रांड को ऑन करता है. आपको एक ऐसा रिजल्ट मिल जाएगा. उसको आप डिवाइड करोगे और बोलोगे कि वो वाली ईआईडीज एसोसिएट आइडेंटिफाई करो विच आर एसोसिएटेड विद ऑल दी बीआईडीज ऑफ ब्रांड. which are associated with all the BIDs of brand. So in the on table, if all the BIDs of the brand table are present, then this option D will produce all the EIDs from the on table. This option D will produce all the EIDs from the on table. And if any of the BID from the brand table is missing, if any of the BID from the brand table is missing in the on table, then this option D will produce empty result, because after this cross product there is no EID which is associated with all the BIDs of brand, because we don't have all the BIDs in the on table. So option D will produce empty result if there is any BID in the of the brand table which is missing in the on table. If all the BIDs of the brand are present in the on table, then option D will produce all the EIDs of the on table from the on table. Make sense? Is it clear? हाँ जी, ऑन वाले से है इसलिए ये रॉन्ग है. So option D, anyway it is wrong, but please try to understand, it's not about right or wrong options. It's about whether you are trying to understand or not that what exactly will be produced by this particular relational algebra expression. Clear? So that's the idea, that look for all the possible options. So this is a very simple question related to concept of join. So it's basically a conditional join and some projection selection operation. So please give me the answer. I just want to know that if you have understood all the operations properly or not. Okay, just 1 minute. You guys solve this. Where is she? Consider the following statement as about the relational data meta. Relational scheme can have at most one foreign key. A foreign key in relation schema R cannot be used. Manish, this will discuss in the relation ER model. Don't worry about that. That concept is related to foreign key, and foreign key will be discussed during the referential integrity constraints. What output will be produced by this particular query? Null or zero you are trying to say? I don't know. Let's check. Consider the following relation. P has 3 attributes XYZ, XYT and YP. Okay, whatever. How many tuples will be written by the relational algebra expression? So first of all, it performs P cross R. It performs P cross R. So this two will be joined. Then the selection condition will be that P dot Y should be equals to R dot Y. So this will join with this. Anything else? No, sir. This will join with this. Okay. This Y2 will join with this. This Y2 will join with this. So first of all, this 4 will be there, and apart from that, R dot V should be equals to V2. In R dot V should be equals to V2. So the only two tuples that will be present is this Y2. Why it is V2? Okay. Sorry. It's asking for variable V. So Y1 will join with this Y1. This Y1 will also join with this Y1. This Y2 will join with this Y2. This Y2 will also join with this Y2. So 4 tuples because of this, and R dot V will be equals to V2. So this is V2, so nobody joins with this. Here it is V2. So you will have only one tuple here. What, sir? X2, Y2, Z2, Y2, V2. That's the result. And from here, you will project X. From here, you will project X. So the result will contain X2. It will contain X2. Yes or no? Sir, what about this? Sir, we will perform Q cross R. Then we'll have Q dot Y should be equals to R dot Y. So this will connect with this. Nothing else. This will connect with this. This will connect with this. This will connect with this. And this will connect with this. So these are the tuples that you will have. Then you will have Q dot T. Q dot T must be greater than 2. So this is not greater than 2, so it will not be chosen. This is not greater than 2, this will not be chosen. So you will have here this is true. So y2 will combine with this y2 will combine with this y2, and this y1 will combine with this y1. So three tuples. So here in the result you will have x1 y1, oh sorry, yeah. X1 y2, then you will have x1 y2, and here you will have x1 y2. So when you project, you will get x1. You will get x1. Now tell me that what will be the number of tuples? Will it be null? Will it be null? Please check and tell me, will it be null? Will it be null? Will it be null? I'm asking for the last time. Will it be null? How many tuples will be present in the output? One tuple will be present in the output. Clear? So you will project the value of x. So this is y1. This will connect with this, but v will not be equals to v1. This is also y1. Connect with this, but v is not equals to v2. This y2 will connect with this y2. V is not equals to v2. This y2 will connect with this y2, and v is equals to v2. Therefore, x2, y2, z2, y2, v2 will be one tuple. And from here you understand that all the values are with respect to x1, because here x2, the only thing, the result can be, the only condition when result can be phi is when with respect to x2 the value of t, with respect to x2 the value of t is greater than 2, but this value of t is not greater than 2, therefore x2 will never get selected. So if anything gets selected, it will either be x1 or x3. If anything it gets selected, it will be either x1 or x3. So with respect to x2, if I subtract x1 or x3, x2 will definitely be present in the result of subtraction. Therefore, the final value that will be present will be x2. The final value that will be present will be x2. And how many tuples? So the number of tuples produced or number of tuples in the output will be 1. Is it clear? Done, sir. Chaliye. So this is the question of outer join. Give me the answer. R is a relation with two attributes AB. S is another relation with attributes BC, where S dot B, look at this, S dot B is the primary key, okay, and R dot B is the foreign key. So foreign key will reference to the primary key or alternate key, so referencing S dot B. So this will refer to this. What does it mean? What do I mean by foreign key? Sir, the values that are present in the column B of relation R are actually from the column B in relation S. Are actually from the column B in relation S. So please try to visualize this. If R have a relation with the two attributes A, B, and S is a relation with the two attributes B, C, do you realize that the question is saying that B is in S is a primary key, therefore all the values of B will be unique, all the values of B will be unique in relation S. And when I say foreign key, that means whatever happens here, I am not worried about that, but the values that are present in B will eventually come from, some values may be null because it didn't say anything, right? So the values that come in the column B will be from the values of column B in relation S. So this is the foreign key. All the values here are the subset of the values in the column B of relation S or null. So this is the foreign key concept. Now consider the query that you want to join R. You want to perform the natural join of R with the tuples from S such that the value of B is less than 5. Okay. So anyway, I'm not worried that what type of values are present. Now let left outer join denotes the natural left outer join operation. Assume that R and S are contained no null values. So so this means this null is not allowed. Otherwise it can take a null value, but he has specified that R and S contains no null values. That's perfectly fine. Which of the following query is not equivalent to Q? So there is a query which is Q and it says that which of the following is not equivalent to Q? Which of the following is not equivalent to Q? Now my question is, if we perform the natural join, if we perform the natural join of R and S, if we perform the natural join of R and S, so you will have the attribute A, you will have the attribute B, you will have the attribute C, and in the natural join you will only have the tuples that satisfy the join condition. So in this particular case, let's take this particular case and have some values of B which are greater than 5 as well, 6, 7, and let's take one value of B as 6. Okay. Now if we perform the natural join, so first of all select the tuples from S in which the value of B is less than 5. So this 4 tuples will get selected. This 4 tuples will get selected. Then you will perform the natural join with R. So if you perform the natural join with R, this one will combine with this one will combine with this 2 will combine with this 2 will combine with this, no other combination will be there. No other combination will be there. So these are the 4 tuples. Whatever this value of is A is, let's call it A1, A2, A3, A4. We are not worried about that. A1, A2, A3, A4, A5, and these values may be C1, C2, C2, C3, C4, C6, I don't care, whatever they are, because B is a key, right? So we'll have A1, 1, C1, A2, 1, C1, A3, 2, C2, A4, 2, C2. These are the tuples which you will get in the result. Now it asks that let LOG denotes the natural left outer join. So which of the following is equivalent to Q? Please try to understand, if we are defining left outer join, then whichever relation is on the left hand side, from that relation, those tuples will also be present. Those tuples will also be present which did not satisfy the join condition. And corresponding to that, the remaining values will be null, or the values of the remaining attributes will be null. So you must understand that, sir, this query Q will not contain any null values. In the output of query Q will only have the tuples of relation R that join with the tuple of relation S such that the values of B in those tuple S are less than 5. So we know that this 4 tuple will join, with the relation S. Now it says that perform the R natural join S and select the tuples such that the value of B is less than 5. Will it be true or not? Option A, is it true or not? If we simply perform, so after the natural join, only those tuples will be combined in which the value of B is less than 5. If we first combine the tuples, or if we first join the tuples of R and S and then we select the tuples in which the value of B is less than 5, so anyway the tuple of R which are being combined with tuple of S will have the same value of B. So if at all the value, so if we simply perform this, then this 6 will join with this as well. The extra tuple that will be present in the R natural join S is that A5, 6 will join with 6C4. Then after that, if you select the tuples in which B is less than 5, so this will get eliminated. So these are the only 4 tuples that will be present. So this is equivalent to Q. This is equivalent to Q, and it is asking which of the following query is not equivalent to Q. Another one is, so it says that first of all R left outer join S. So it says that first of all R left outer join with S, that is join all the tuples of R. Now the idea is, please try to understand if we have B in relation R as foreign key, then is it possible to have any value in the column B of relation R which is not present in the column B of relation S? So please try to understand, because B is a foreign key, so each value is guaranteed to map with at least one tuple of, or each value of relation R is guaranteed to match with exactly one tuple of relation S. So in R left outer join S, the result will be exactly same as R natural join S. The R left outer join S will be exactly same as R natural join S. Why? Because there is no tuple in R which will fail the join condition with relation S on attribute B. Yes or no? Please try to understand. This R left outer join S will be equals to R natural join S. Yes or no? R left outer join S will be equivalent to R natural join S. Yes or no? Yes, because there is no tuple in the relation R which contains a value of B which will not be present in the column B of relation S. Therefore, each tuple of relation R will join with exactly one tuple of relation S. Therefore, there will be no extra tuple in the relation R with respect to which we will have to specify the value of C as null. So, this is also equivalent to Q, because if it is equivalent to R natural join S, then A and B are same. A and B are same. Again, this C is also same. Let's look at this. So this is nothing but, first of all, we are selecting the tuples, then we are selecting the tuples from S in which the value of B is less than S. Then you are performing R left outer join S. Now tell me, result of option C will be same or not? Somebody said that option D is the correct answer, but option D is wrong. Sorry, option C is also wrong. Please try to understand. If we have first selected the tuples, if we directly perform the left outer join of R and S, then all the values which are present in R are guaranteed to be present in relation S. But if you have first removed some tuples from relation S such that the values are greater than 5, so these two tuples will not be present after this selection condition. This two tuple will not be present after this selection condition. Then if you perform the left outer join with this four tuples, then this A6 will have the value of C as null. Do you realize that this tuple will also be present in the answer of option C? A5, 6 null will also be present in the output of option C. Yes or no? Value of A will be A5, value of B will be 6, and value of C will be null. This tuple will also be present in the output of option C. Make sense? So, if you try to understand the queries properly, you will be able to figure out that this is not equivalent to Q. This is not equivalent to Q. What about option D? So, it says that take the tuple from relation R in which the value of B is less than 5, then perform the left outer join with S. So, if you have selected the tuples from relation R in which the value of B is less than 5, so you will remove this tuple from relation R, then you will join. So, then also when you will join, then all these values are less than 5, therefore they will combine with all their respective tuples, and the result of this option D will also be equivalent to Q. There is no tuple in the relation R. There is no tuple in the relation R which will have the some values of attribute B which are not present in S. Therefore, all the tuples of relation R in which the value of B is less than 5 will match with exactly one tuple of relation S, and the result of option D will also be equivalent to Q. Result of option D will also be equivalent to Q. Done? Any doubt? Simple question of natural join and left outer join, but so much confusion. Clear? Any doubt? So please try to understand. These are the questions for which you will say that, sir, I am not able to find the correct answer of the questions. The only problem is that you are not thinking properly. I am not using any concept which we did not discuss. But the only thing is whether you are able to apply those concepts in a question or not. You don't need any extra knowledge. You don't need any extra knowledge. The only thing is that whether you are able to relate the question with the concept that you already know or not? Next one. Give me the answer. Again, another question of division. Two-mark question. Sir, please try to understand the questions in which table is given will always be damn easy. So, the question may look lengthy. The question may look lengthy, but please try to read the question patiently and you will be able to solve each and every question in which the table is already given. If the table is already given, that relational algebra query or SQL query will be damn easy. So consider a database that has a relational schema CR, which has a student name and course name. An instance of the schema CR is given. So there is an instance of this CR, right? Now, the following query is made on this database. Please try to understand. Hello. These are not two different tables. I don't have enough space to define those many tuples on a single slide. Therefore, after this, we have this sequence of tuples. So please don't get confused. Is it clear that that's how the question is defined? The table was quite lengthy and I was not able to draw it on a single slide. Therefore, all these tuples are the member of this single table CR. Okay. Now what happens? Following query is made on this database. So first of all, what does it do? Sir, from CR table, it selects the student name SA. So this will get selected, this will get selected, this will get selected. Yes or no? And the CR in which the student name is SA, from there they project the course name. So you will have CA, CB, CC. These are the three courses which will be present in the output. So if we look at T1, then T1 will have only one column, that was C name, and it will have three courses CA, CB and CC. Make sense? Another query is, so this is T1. Now it says that if we divide CR by T1, then what will be the output? So CR has only two attributes. Please try to understand. So CR has two attributes, the student name, comma, course name. Right? Now you are dividing it by course name of T1. Now you are dividing it by course name of T1. So now what will you get? You will get the student name which are associated with all the course name of T1 table. So that means you will get the student name who are associated with all these three courses CA, CB and CC. Right? So when you do this, sir, obviously SA will get selected. SA will get selected because SA is guaranteed to be associated with CA, CB, CC. Now SB will not get selected because SB is associated with CB and CC, but it is not associated with CA, right? Now SC is associated with CA, CB, CC, therefore SC will also get selected. Sir, SD is associated with CA, CB and CC, therefore SD will also get selected, right? Sir, SE is DA, CA, CB, so SE. So CA and CB, but it is not associated with CC, therefore it will not get selected. CA, CB, CC, it will also get selected. So in the output, you will get in the output the student's name which you will get will be SA, SC, SD and SF, right? So it asks for the number of tuples. In the output it will be 4. Clear? Why 16? Why 16? Done? सर मैं अभी यही पूछने वाला था आपसे. Done? So I am not doing anything new. I am only applying the concept that you already know. Okay, this is the question. Very good question. This is a good question. You may think that this is not a good question, but for me it's a good question. You are a good question. क्या नाम है उस एक्टर का? तनु इट्स मनु. You are a good question. Though it's an old question, but still, I find it good. भाई कैसे ही करेंगे, जब तक हमने रिवीजन नहीं किया तब तक क्वेश्चन क्या कराने का फायदा है। तो उसको लपेटेंगे हम हमारे अभ्यास में, है ना। इसीलिए पहले यहाँ पर ये दोनों टॉपिक कर लेते हैं, फिर अभ्यास में बाकी सारे कर लेंगे। ऑप्शन बी 1 and 3, 1 and 3. Okay. Okay, let R and B as be two relations with the following schema. R has PQ R1 R2 R, or let's whatever PQ R1 R2 R3, whatever it is. Okay, S has PQ S1 S2, PQ S1 S2. Here PQ together forms the key. Here also PQ together forms the key. So do you realize that the values of PQ will be unique in relation R and values of PQ will be unique in relation S as well. Now, where PQ is the, okay, it is given, where PQ is the key for both the schema, which of the following queries are equivalent? Please try to understand. If you perform the R natural join S, so what are the common attributes? If you perform the R natural join S, what are the common attributes between R and S? So the common attributes are P and Q. So please try to understand. What will you do? Sir, you will perform R cross S. Then from R cross S, you will select the tuples such that R dot P is equals to S dot P and R dot Q equals to S dot Q. So that means whatever the values of PQ are present in relation R, same values of PQ must be present in relation S, then only those tuples will be selected. So, and then you will project P. So please try to understand, when you are saying that the values of PQ which are present in relation R will be combined with values of PQ which are present in relation S, is it possible that one value of PQ appears more than once in relation S? One combination of PQ appear more than once in relation S. So either a tuple of R will not relate with any tuple of S, either a tuple of R will not relate with any tuple of S, or if at all it relates, then a tuple of R will relate with exactly one tuple of S. Yes or no? Either a tuple of R will not relate a tuple with a tuple of S. If at all a tuple of R relates with a tuple of S, it will relate with exactly one tuple of S. Or is it possible to relate with more than one tuple? No, sir, because these are keys. So here, if at all the value 1, 2 is present, then it will be present in only one tuple. If at all value 1, 2 is present, then 1, 2 is present here, then it will match with exactly one tuple in which value will be equals to 1, 2, otherwise value will be 1, 3 or some other value, right? So if at all a tuple of relation R relates with a tuple of relation S, it will relate with exactly one tuple, and it will relate with a tuple in which the values of P and Q are same. So then finally you will project P. Then finally you will project P, right? So I can simply say that from this common values we will project P. Now the idea is, sir, from R cross S, if we are selecting the tuples in which the R dot P equals to S dot P and R dot P equals to S dot Q, then basically you must understand that you are not interested in the remaining values R1, R2, R3, S1, S2. So you are interested only the value of P and Q. You are interested only in the values of P and Q. So this is statement 1. Now, which of the following 1 is equivalent? So it's actually from the natural join, it is selecting the value of P. Now here it is selecting the value of P from R, it is selecting the value of S from value of P from S, and then it is performing the natural join. So my question is, let's look at this. So this is your relation R. Forget about other values. Let's only focus on P and Q. This is your relation S. Forget about other values. Just focus on values of P and Q. Now my question is, if there is a value 1, 2, there is a value 1, 2, there is a value 1, 4, or there is a value 2, 4, and there's a value 3, 5. My question is, this first query will produce, in the output of the first query, the answer will be 1. In the output of the first query, the answer will be 1. Yes. In the output of second query, what will happen? Sir, you will project 1, 2, you will project 1, 3. So here, you will project 1, 2, you will project 1, 3. Here also the answer will be 1. In this specific case, the answer will be 1. But my question is, sir, if it is the case that this value is not 1, 3, but this value happens to be 1, 3. If this value happens to be 1, 3, then with respect to first query, what will be the output? Sir, 1, 2 does not match with 1, 3, 1, 2 does not match with 3, 5. 2, 4 does not match with 1, 3, 2, 4 does not match with 3, 5. So, with respect to first query, answer will be 5. Whereas, with respect to second query, it will project two values 1, 2, it will project two values 1, 3. When it joins 1, 2 with 1, 3, the result will be 1. So, can I say that first is definitely not equivalent to second? Can I say first is definitely not equivalent to second? Sir, in the first query, the comparison condition is on both P as well as Q. That is, both P and Q should be same. So, here we are saying that here it is 1, 2 and it is 1, 3, then it will not match because both P and Q should be same. But the second query is only comparing the value of P, that if the values of P are same in R and S, then those values of P will be present. Those values of P will be present. So, first one compares the value of P as well as Q, whereas second one compares the value of P only. Now, let's look for this second one. Please try to understand. You are saying that from relation R, you need to project PQ. From relation S, you need to project PQ. Then you need to make, sir, once you have projected PQ, then R and S. So, this projection and this projection becomes union compatible. We cannot simply perform R intersection S is invalid. Yes or no? R intersection S is invalid. Why? R intersection is invalid because they are not union compatible. Union compatible, they have different number of tuples. They have different number of tuples. Oh, sorry, different number of attributes. But once you have projected PQ from S, once you have projected PQ from R, then you will have only these two values, you will have only these two values. What happens with other? It does not matter. Now what will happen? If at all there are some common values, if at all there are some common values of PQ in R and S, then those values will be selected. So, if 1, 2 is present here and 1, 2 is present here as well, then 1, 2 will get selected, which was the case with the first example. And from those common tuples, P will get selected. So, do you realize that first one will be actually equivalent to third one? Because we are selecting the tuples in which we are selecting the values of P and Q, in which both P and Q, in which the values of P and Q are same in R as well as in S, and from those values of P and Q, you are selecting P. So, you are first selecting the values of P and Q such that they are common in R and S, and from there you are selecting the value of P. So, first is actually equivalent to third. First is actually equivalent to third. So, what about fourth one? So, okay, this is interesting. This is interesting. Sir, you are selecting PQ from R, then you are selecting PQ from R, then you are selecting PQ from S. So, sir, R minus S is what? R minus S is what? Sir, select PQ from R minus S. So, is it not equivalent to, sir, is it not the derivation of intersection? Is it not equivalent to from R project PQ intersection from S project PQ? Please try to understand. So, derived relation algebra operations. So, this minus this minus this. This is actually intersection. This whole thing is actually the derivation of intersection. So, we can actually see the third one is actually equals to fourth one. Third one is equivalent to fourth one. So, in first, third and fourth, we are first selecting the common, we are selecting the tuples in which the values of P and Q are common, and from those common values of P and Q, we are selecting the values of P. But in the second one, we are selecting the common values of P in R and S. We are not focused about value of Q. So, second one is not equivalent. All other three are equivalent. So, the correct answer will be 1, 3 and 4. So, the correct answer is D. Clear? So I hope you understand that's a simple intersection and natural join question, but you must have proper understanding of all the relational algebra operations to answer this question. Done? See, if it becomes an MSQ question and some of you thought it as 1 and 3, if you skip any one of the 3, then you will get 0 marks. Clear? Next. Okay, we are done with relational algebra. So the important concept in the relational algebra is of division and natural join and all those. Apart from that, the query of the relational algebra will have simple cross product and the condition is specified with those cross products. So cross product and the condition is specified with the cross product will be the easiest thing to solve. Clear, sir? SQL का topic वो उसके अंदर से गायब हो गया भाई, मैं समझा दूंगा, डोंट वरी। उसके अंदर से जो चीज मिसिंग है वो मैं यहाँ पर एक्सप्लेन कर दूंगा क्वेश्चंस के साथ, है ना। The only thing that is missing in that particular video is the order of execution of correlated subquery, the order of execution of correlated subquery and 4 operators in, any, all and exist. एसक्यूएल में कंफ्यूज नहीं हो, रिलेशनल अलजेब्रा में कंफ्यूज नहीं हो, जो हो रहा है वो खत्म कर लो, धीमे धीमे सारा खत्म कर लेंगे बेटा। कंफ्यूजन तो हर जगह ही है आपको, जो चल रहा है उस पे हमारा बस फोकस नहीं है, हम जो नहीं चल रहा है उस पे हमारा पूरा प्रॉपर फोकस है। हाँ जी, जो चल रहा है उस पे फोकस नहीं है, बाकी पूरी दुनिया पे फोकस है। एनी आंसर फॉर दिस क्वेश्चन? किसी ने कल मुझसे कहा था, what was the name of that student, कि sir please take GATE 2009 question when I was discussing about in operator, when I was discussing about in operator, he asked, चले please try to understand before I proceed. I know that, but I'll be quick in this particular case. So you need to understand the order of execution with respect to correlated subquery. So I'll be quick, but I'll not skip this. So let's assume that if I say select a string from R where some operator then you specify select a string from S where R dot A goes to S dot B, right? So what is the order of execution? So sir, this is actually the operand for this operator. If this operator is true, then where condition true. If this operator returns false, then this where condition is false. ठीक है, ये है बेसिक कॉन्सेप्ट। अगर ऑपरेटर ट्रू रिटर्न करता है तो वेयर कंडीशन ट्रू है, अगर ऑपरेटर फॉल्स रिटर्न करता है तो वेयर कंडीशन फॉल्स है। ठीक है, बट इस ऑपरेटर को परफॉर्म करने के लिए, इन ऑर्डर टू परफॉर्म दिस ऑपरेशन we need the operand. In order to perform this operation, we need the operand. So what will be the order of execution? Sir, in the relation R, you will have some tuples. This is your relation R. Let's assume that this is your attribute A, and you will have some tuples. This is your relation S, and this relation S. Let's assume that this is your attribute B, and you will have some tuples. So how exactly it will execute? Sir, first of all, you will take a tuple from relation R. You will take a tuple from relation R. So let's assume you pick up this tuple. So once you pick up this tuple, the value of attribute A from the first tuple is available. Then you will go to this inner query. So after from you must execute where, but to execute where you need the operand. of this operator. In order to get the operand, you need to execute this inner query. So in order to execute this inner query, this will be a query on the complete table S. This is a query on the complete table S. So first of all, you will pick up the first tuple of relation S. That means the value of attribute B from the first tuple is available. So once you have picked this particular tuple, so you have a first tuple from relation R, you have first tuple from relation S. So you have the value of attribute A from first tuple of relation R, you have the value of attribute B from first tuple of relation S. Then you can go and you can check this where condition with respect to first tuple of R and first tuple of S. Now, if this condition happens to be true, then this first tuple of relation S will be selected. If the condition happens to be false, first tuple of relation S will not be selected. But the operator or the operand of this operator is the output of this complete query. So merely the comparison with the first tuple of relation S will not work. Therefore, then you will have to execute this inner query on the second tuple. So now you will pick up this second tuple. So still you have the first tuple from relation R in your hand, and then you have the second tuple of relation S. So you have the value of attribute A from the first tuple of relation R and value of attribute B from the second tuple of relation R. So you will again compare this condition. If this condition is true, second tuple of relation S will be selected. If condition is false, second tuple of relation S will not get selected. So done with respect to second tuple as well, that second tuple should be selected or not with respect to first tuple of R. Then you will go and the third tuple and so on. So once you have scanned the complete table S, with respect to first tuple of R, you will have the output of this inner query with respect to first tuple of R. You will have the output of the inner query with respect to first tuple of R. Once you have the output of inner query with respect to first tuple of R, you will be able to decide whether this operator will return true or false. You will be able to decide whether this operator will return true or false. So if this operator returns true, the first tuple of relation R will get selected. If the operator returns false, then the first tuple of relation R will not get selected. Now what? So now pick up the second tuple and repeat the process. So second tuple will be compared with the first tuple of S, second tuple will be compared with the second tuple of S, second tuple of R will be compared with the third tuple of S, and so on. It will be executed on the complete table S. Once you have compared with all the tuples of relation S, you will know the output of inner query with respect to second tuple of R. Based on that, you will check whether operator will produce true or false. Based on that, you will decide whether the second tuple of R will get selected or not. Right? Okay. So this is the operator which will produce true or false. So there are various operators: in, any, all, exist. In. So if the value present from the tuple of outer relation, is present in the set of tuples produced by inner query, then in will return true. If the value present in the tuple of outer relation is not present in the values produced or in the set of tuples produced by inner query, then in will return false. So please try to understand, complement of in will be not in. So if the value present in the tuple of outer relation is not present in the set of tuples produced by inner query, then not in will return true. So in complement is not in. So with respect to in, complement is not in. So it's a simple concept. In this set of tuples or not? It looks for a simple thing, that the value is in this set of tuples produced by the inner query or not. So if it is in this set of tuples, the in operator in will return true. If the value is not in this set of tuples, operator in will return false. So when in will return false, not in will return true. Okay. So any will have, so the value, so any operators will be used along with other comparison operator, less than, greater than, less than, equals to, greater than, equals to, not equals to. So if I say x less than any of, let's say assume the inner query produces the result 2, 4, 7, 9, 8. And if I say that x equals to 5, so 5 less than 2, no sir, 5 less than 4, no, 5 less than 7, yes. So as soon as any tuple in the set of tuples satisfies this comparison condition less than, then any will return true. If there is no tuple in the set of tuples with respect to which this comparison condition is true, then any will return false. So if x equals to 5, any will return true. Let's say assume if I say x equals to 10. So 10 is not less than 2, 10 is not less than 4, 10 is not less than 7, 10 is not less than 9, 10 is not less than 8. So no tuple in the set of tuples satisfy the comparison condition, then any will return false. Clear? So please try to understand. Any will return true if at least one tuple in the set of tuples satisfies the comparison condition. Any will return false if no tuple in the set of tuples satisfies the comparison condition. Now you must understand, if inner query result is empty, let's say assume that inner query produces an empty result or empty table. So if inner query result is empty, in will always return false and not in will always return true. Similarly, if inner query result is empty, there is no tuple in the set of tuples with respect to which this comparison condition will be true. So there is no tuple in the set of tuples with respect to which comparison condition is true. Therefore, if inner query result is empty, any will always return false. Any will always return false. Sir, with respect to all, so same situation with all, that all will return true or false. So this is with respect to any. So let's assume if I say x greater than all and the set of tuple is 2, 4, 3, 7, 9. So if I say that's x equals to 5. So 5 greater than 2, yes. 5 greater than 4, yes. 5 greater than 3, yes. 5 greater than 7, no. So if any tuple in the set of tuples fails the comparison condition, then all return false. If I say x equals to 10, so 10 greater than 2, yes. 10 greater than 4, yes. 10 greater than 3, yes. 10 greater than 7, yes. 10 greater than 9. So is there any tuple in the set of tuples with respect to which this comparison condition fails? No, sir. Then all returns true. So please try to understand, any will return true if at least one tuple in this set of tuples satisfies the comparison condition, and if there is no tuple, then it will return false. So all the focus of all is on false. As soon as any tuple in the set of tuples fails the comparison condition, all will return false and it will not check with the remaining tuples in the set of tuples. So the focus of any is to search for a tuple in the set of tuples with respect to which this comparison condition is true, so that it can skip the remaining tuples, whereas the focus of all is to check if there is any tuple with respect to which this comparison condition fails. So if there is any tuple with respect to which comparison condition fails, it will return false, otherwise it will return true. So you must understand that if there is no tuple in the set of tuples, that means if inner query result is empty, then there is no tuple with respect to which this comparison condition will fail. So if the inner query result is empty, then all will always return true, right? Any will always return false if inner query result is empty. Always return true if inner query result is empty. Sir, exist is very simple. If inner query result is empty, then exist will return false. If inner query result is not empty, then exist will return true. So exist will return true if and only if. Exist will return true if and only if inner query result is not empty. So if not empty, exist returns true. If empty, exist returns false, and complement of exist is not exist. Oh. So when inner query result is not empty, exist will return true, but not exist will return false. Clear? Anyway, so this is from the last 45 minutes of the last session. Now look at this question. My only concern here is that what is the output of this query? What is the output of this query? So in order to execute subquery, the very first thing that you need to understand is whether the subquery is a correlated subquery or an independent subquery. So देखो, sir, consider the following relation schema: supplier table. So SID is the key, S name, city, street, right? Parts, PID is the key, name of the part, color of the part, catalog table, SID and PID together forms the key, and cost of that particular part may be real. So real is any real value. So consider the following relational query on the about database. So it selects from supplier, so it's renamed as S. What did I say? If you simply provide a new name by specifying in a space. If you perform a comma, if you write a comma, it will try to look for the table S and it will perform the join of these two tables. But if you simply specify S by a space, then it will rename suppliers into S. Now what will happen? So supplier relation will be renamed into S. Then where? So it will check where. So which tuple of the supplier table will get selected, for which this not in returns true, for which this not in. So this is your operator. So if SID is not in this set of tuples, if SID is not in this set of tuples, so we need to execute this inner query. We need to execute this inner query to check whether this not in will return true or false with respect to a tuple of supplier table. So we'll go that what exactly is happening within this inner query. So it selects the SID from the catalog table provided C.PID is not in. देखो, we have outer relation as S. In the inner query, we need C and select P.PID from parts P. Now my question is, sir, here from catalog C, we will select the tuple provided this not in is true. So this not in will again check for the output of this inner query. Now it selects for the PID from parts P where P.color equals to blue. My question is whether this query can be executed independently or not. This query that I have circled using purple color can be executed independently or not. वो नहीं मिलेगा बेटा, that's gone. So it can be executed independently. So it's a independent subquery. First of all, this subquery will execute. Innermost query will execute first. Innermost query will execute first, and it is independent, so it can be executed independently. So let's execute this. So what exactly will be produced by this? Select PID from parts where P color is not equals to blue. So it will select the PIDs of non-blue color parts. What exactly will be produced by this? It will select the PIDs of non-blue color parts. Let's select PIDs of non-blue color parts. So once we have the PIDs, let's assume that we have a parts table. In this parts table, we have some parts P1, P2, P3. P1 is red, P2 is blue, and P3 is green. Whatever the color is, it does not matter, right? So we know that the output of this query will be P1 and P3. Why? Because these are the PIDs. Output of this query will be P1 and P3. These are the PIDs of non-blue color part. Make sense? Okay. Now once you have executed the inner query, which is independent query, you can execute the outer query. Now please try to understand what exactly will be produced by this particular query. So it will select the tuples from the catalog where PID is not in the set of non-blue color parts. So please try to understand. If there is a tuple from the catalog, and in that tuple, if the PID is not in this set, if PID is not in this set, so PID in this set, that means the color of the part supplied by that supplier is non-blue, right? But if the color is not in this set, so these are all the PIDs of non-blue color parts. Apart from that, all the PIDs are of blue color. Apart from that, all the PIDs are of blue color. Yes or no? Apart from this PIDs, P1, P3, all other PIDs are of blue color. So, if the PID is not in this set, means the PID that you are looking for must be of blue color. So, PID is not in this set, then the PID is of blue color. So, if PID is not in this set, that only not in will return true. So PID is not in this set, then only not in will return true. So not in will return true if the PID is of blue color part. So if the PID is of blue color, then it will not be in the set of non-blue color parts. So this where condition will be true when the PID is of blue color. So it will select the SIDs of the suppliers who have supplied some blue color parts. Yes or no? So this not in will be true only for those tuples in which the PID is of blue color. So it will select the SIDs of the suppliers who have supplied some blue color parts. Okay, let's try to understand the outermost query. Sir, outermost query is using the supplier table. So supplier table may also contain the information. Supplier table may contain the information of those suppliers as well who did not supply any part. So let's assume this is your supplier table. In this supplier table, we have the SIDs S1, S2, S3, S4, right? So this is your catalog table. In the catalog table, S1 supplied P1, S1 supplied P2, S2 supplied P2, S3 supplied P3. So this is just the information that I have. So from the catalog table, P1 is in this set, therefore S1 will not get selected. P2 is not in this set, therefore for this P2, this tuple will be selected. Therefore output will contain S1. In the output, you will have S1. Sir, S2, sir, with respect to S2, PID is P2 and P2 is not in this set, therefore not in will return true, therefore S2 will also get selected. Right, S3, sir, S3 have supplied P3, P3 is in this set, therefore in will return true and not in will return true, not in will return false. So output will be the SIDs of the supplier. Sir, S1 have supplied some blue color part, S2 also have supplied some blue color parts. Therefore, this red color circle wali query will produce the SIDs of the suppliers who have supplied some blue color parts. Now what will happen? So you will execute the outermost query. So you will select the tuples from supplier table. If the SID in the tuple is not in not in the set of suppliers who have supplied some blue color parts, then if the SID is not in this set, then only this not in will return true. So with respect to S1, with respect to ये जो query है, this will produce S1 का जो नाम है, right? Whatever the name is, but name of S1, right? So S name की बात हो रही है, but will be with respect to S1. So S1 is in this set of SIDs or not? Yes, sir. S1 is in this set, therefore S1 will not get selected. S2 is in this set or not? No, sir. Yes, sir. S2 is also in this set, so S2 will not get selected. S3 of the third tuple is in this set or not? No, sir. Therefore S3 will get selected. S4 is in this set or not? Yes, sir. S4 will also get selected. So, sir, S3 and S4 are the suppliers who did not supply. S3 and S4 are the suppliers who did not supply any red color, any blue color part. S3 and S4 are the suppliers who did not supply any blue color part. So this produces the SIDs of the suppliers who have supplied some blue color parts. If the SID is not in this set, that means that supplier have not supplied any blue color part. That supplier have not supplied any blue color part. So if you try to understand that what exactly will be produced by this outermost query, so this outermost query will produce the S names of the suppliers who did not supply. S name of the supplier, output will be what? S name of supplier who did not supply any blue color part or not supplied any part. So do you realize that supplier S4 did not supply any part, so is also selected. Now look at the option. It says find the names of the suppliers who have supplied non-blue parts. Are we looking for the SIDs of the suppliers who have supplied non-blue parts? So we are looking for the output is the SIDs of the supplier who did not supply any blue part. We are saying, sir, SIDs of the suppliers who have supplied a non-blue part. No, sir, we are looking for the suppliers who have not supplied any blue part. So any blue part, so it is not necessary for him to supply a non-blue part because S4 is being selected and S4 did not supply any non-blue part. S4 did not supply any non-blue part, therefore option A is false. Option B, find the names of the supplier who have not supplied a non-blue part. Who have not supplied. Look at this. Who have not supplied a non-blue part. We are looking for the SIDs of the supplier who has not supplied any blue part. We are looking for the SIDs of the supplier who did not supply any blue part. So when we say SIDs of the supplier who did not supply any blue part, does it mean find the names of the suppliers who have not supplied a non-blue part? Find the SIDs of the suppliers who have not supplied a non-blue part. Who have not supplied a non-blue part means SIDs of the suppliers. This statement is ambiguous. That's why I am discussing this question. Find names of all the suppliers. Find names of all the suppliers who not supplied a non-blue part. So S1, S3 supplied a non-blue part or not? So S3 supplied a non-blue part. S3 supplied a non-blue part. So when you say who have not supplied a non-blue part, no sir, it may select the suppliers who have supplied a non-blue parts provided he did not supply any blue part. Provided he did not supply a blue part. So find the names of all the suppliers who have supplied only blue parts. Come on sir, we are looking for the SIDs of the supplier who did not supply any blue part, and you are saying that it selects the SIDs names of the suppliers who have supplied only blue parts? No, right? S3 supply not blue part, and it says not supplied a not blue part, right? So option B is false. Find the names of all the suppliers who have not supplied only blue parts. Now that's the statement which creates confusion. So other three are wrong. The statement says find the names of all the suppliers. Option D says find the name of all the suppliers. Ashutosh, listen to this carefully. Find the names of all the suppliers who have not supplied only blue parts. What does it mean? What exactly is the interpretation of option D? That's where you commit mistake, or that's what they have committed mistake. Sir, the option D means find the names of all the suppliers who have not supplied only blue parts. That means they have supplied some other color parts as well along with a blue color part. What is the interpretation of this option D? That means you are looking for the suppliers. No. Find the names of all the suppliers. It finds, listen to me carefully and try to read this point to point. Find the names of all the suppliers. Find the names of all the suppliers who have not supplied. Find the names of all the suppliers. What happened? Find the names of all the suppliers who have not supplied only blue parts. Who have not supplied only blue parts. What does it mean? They have supplied some other parts along with blue color parts. When you say find the names of all the suppliers who have not supplied only blue parts, what does it mean? That means they have supplied some other parts along with blue color parts. They have not only supplied blue parts, but they have supplied some other color parts as well along with blue color parts. Yes or no? ब्लू के साथ साथ कोई और सप्लाई करना जरूरी है, तभी उसकी एसआईडी सिलेक्ट होगी. Who have not supplied only blue parts. Not supplied only blue parts means they did not supply only blue parts. They have supplied some other color parts as well along with blue color parts. Yes or no? They have supplied some other color, non-blue color parts as well along with blue color part. Yes. So this statement D also becomes false. Therefore, none of these four options is a correct option. They have asked this question in the GATE exam, but none of them is a right answer. Some platform will try to convince you with respect to option D, but it's not correct. Clear? Make sense? Option D is wrong. All four options are wrong. So no correct answer. No correct answer. In option B, it means suppliers who supplied only the blue parts. In option B, find the names of suppliers who have not supplied non-blue parts. Yes, who have not supplied non-blue parts means either they have supplied or not supplied non-blue parts. That means they have supplied only blue parts, or not supplied any part? They have supplied a non-blue part, or they have supplied only blue parts, or did not supply any part? साक्षी मैडम, करने का कुछ है ही नहीं. अब अगर क्वेश्चन गलत है तो आप कुछ भी करके क्वेश्चन गेट में उसको सही नहीं कर सकते. So it will be marks to all. Yes, it will be a marks to all. If such question comes in the GATE exam, it will be marks to all. You cannot do anything. Clear? Okay, silly question that they have asked in the GATE 2023. Give me the answer. Beta, it's an old story. The question is from 2009. At that time, they did not even specify that which answer they are considering correct. So at that point of time, we didn't even know that which answer is being considered correct by the GATE authorities, and even if we know that they are considering a wrong option, we didn't have any choice to challenge them. It all started from 2012. It all started from 2012. In the previous question, there was no marks to all, nothing like that. So consider the following table named student in a relation database. The primary key of the table is roll number. Okay. Now the SQL query below execute on this database. So the only thing was to explain some simple questions as well. So select asterisk from student. Select asterisk means everything from a student. So what's the order of execution? First of all, from. So select the complete table where gender equals to female and marks is greater than equals to 5. So it will not get selected. Let's choose. So gender is not female, so it will not get selected. Gender is female and marks are greater than 65, so it will get selected. Gender equals to female and marks are greater than 65, so it will get selected. Gender equals to male, it will not get selected. Gender equals to female, but marks are not greater than 65, so it will also not get selected. Right? So this is the second thing that will happen. Then select asterisk. So how many total tuples? Sir, these two tuples will get selected. These two tuples will get selected. So the number of rows returned by the SQL query is 2. So not all the questions are tough. Not all the questions are tough. Please try to understand that if you are lucky, you will get such type of questions. But do you realize that if such type of questions are asked, there is no point of putting that much efforts. There is no point of preparing for a whole year, because each and every student will be able to score these 2 marks. You must get some quality questions in the exam so that a difference can be created among the sincere student and non-sincere students. So such questions should not appear in the GATE exam. Getting the idea? ऐसा क्वेश्चन नहीं आना चाहिए, वही तो मैं कह रहा हूं हलदर जी. अगर ऐसा क्वेश्चन आया तो आपको अकेले को 2 नंबर नहीं मिलेंगे, सबको 2 नंबर मिलेंगे. इसका मतलब कोई फायदा ही नहीं है इन क्वेश्चंस का. There is no point of such stupid questions. Okay, give me the answer of this question. जी हाँ, मैं चाहता हूं एग्जाम में टफ क्वेश्चन आए, तभी तो आप लोग अगर उसको सॉल्व कर पाए तो आप अपने आपकी रैंक इंप्रूव कर पाओगे. क्वेश्चंस हमेशा टफ ही आने चाहिए. अगर क्वेश्चंस इजी आ रहे हैं तो कोई भी 2-4 तुक्के एक्स्ट्रा मार करके और IIT पहुंच जाएगा. प्लीज ट्राई टू अंडरस्टैंड. अगर सारे क्वेश्चंस आसानी आ रहे हैं तो मान लीजिए मैक्सिमम क्वेश्चन 70%, 70 मार्क्स के क्वेश्चन आसान थे, देन सबने कर लिए। सोचो जरा सिचुएशन, 70 मार्क्स के क्वेश्चन आसान थे, सबने कर लिए, 30 के बहुत टफ थे, या तो बहुत आसान या तो बहुत टफ। तो 70 मार्क्स के बहुत ही आसान थे, सबने स्कोर कर लिया। 30 के बहुत टफ थे, अब जो बहुत टफ थे उसके अंदर जिसको आता था उससे बने नहीं, लेकिन उसने ये सोच करके कि यार मैंने तो पढ़ाई की है तो मैं नेगेटिव मार्क अफोर्ड नहीं कर सकता, तो वो कुछ करेगा नहीं। और जिसने कुछ पढ़ा नहीं होगा वो तो ओम नमः शिवाय करके 5-7 आंसर मार देगा, और उसके गलती से 3 सही हो गए तो वो आईआईटी पहुंच गया, जिसने मेहनत की थी वो घर में बैठा हुआ है। सो क्वेश्चंस हमेशा मॉडरेट एंड मॉडरेट टू टफ लेवल के आने चाहिए। अगर क्वेश्चन इजी है या क्वेश्चन टफ है तो किसी का फायदा नहीं। अगर क्वेश्चन ज्यादा ही आसान है या क्वेश्चन बहुत ज्यादा टफ है तो उससे किसी का फायदा नहीं। फिलोसॉफी समझो ना, कितना इजी कॉन्सेप्ट है। कंसिडर फॉलोइंग डेटाबेस टेबल, नेम टॉप स्कोरर। सो दिस इज योर टॉप स्कोरर टेबल। कंसिडर दी फॉलोइंग एसक्यूएल क्वेरी, सिलेक्ट टीए। सर इसने बोला है टीए डॉट प्लेयर। सर ये टीए कहां से आया, अभी एक समझ में आएगा। टीए डॉट प्लेयर फ्रॉम टॉप स्कोरर एज अ टीए। सो एज नाउ आई टोल्ड यू, या तो आप सीधे सीधे स्पेस दे करके टॉप स्कोरर टीए लिख देते तो टॉप स्कोरर टीए से रीनेम हो जाता, या तो आप एक्सप्लिसिट रीनेमिंग, आप एक्सप्लिसिटली बोल रहे हो कि एस का यूज करके हम एक्सप्लिसिटली चीजों को रीनेम कर सकते हैं, एस का यूज करके हम एक्सप्लिसिटली चीजों को रीनेम कर सकते हैं, तो टॉप स्कोरर को हम टीए से रीनेम कर रहे हैं। ठीक है, तो हमने एक बार इस टॉप स्कोरर को बोला टीए टेबल। ठीक है, फिर हमने क्या बोला, वेयर टीए डॉट गोल्स, तो टीए के अंदर जो गोल्स हैं, टीए के अंदर जो गोल्स हैं, दे मस्ट बी ग्रेटर देन ऑल। अब देखो ये आ गया ऑपरेटर आपका, दे मस्ट बी ग्रेटर देन ऑल। सो ये कब ट्रू रिटर्न करेगा, ये कब ट्रू रिटर्न करेगा सर, ये तब ट्रू रिटर्न करेगा जब इनर क्वेरी रिजल्ट का कोई भी टपल इस कंपैरिजन कंडीशन को फेल ना करे। समझ गए बात को? ठीक है, नाउ अंदर जाता है, सिलेक्ट डीबी डॉट गोल्स फ्रॉम टॉप स्कोरर एस टीबी। सुनो अच्छे से, टीबी डॉट गोल्स फ्रॉम टॉप स्कोरर एस टीबी, तो इस सेम टेबल को टीबी भी बोला गया। अंदर वाली क्वेरी ने इसको टीबी बोला, बाहर वाली क्वेरी ने इसको टीए बोला। अंदर वाली क्वेरी ने इसको टीबी बोला, बाहर वाली क्वेरी ने इसको टी ए बोला। अब अंदर वाली ने क्या बोला, वेयर टीबी इक्वल्स टू कंट्री इक्वल्स टू स्पेन, तो टीबी के रिस्पेक्ट में स्पेन कहां पर है? सर स्पेन कहीं पर है क्या? स्पेन कहीं पर है क्या? सर स्पेन तो कहीं पर भी नहीं है, तो ये तो फॉल्स हो गया। सर कंट्री कहीं पर भी स्पेन है क्या? नहीं सर, कंट्री तो कहीं पर भी स्पेन नहीं है। तो अगर कंट्री स्पेन नहीं है तो ये वाला जो था, सिलेक्ट टीबी डॉट गोल्स फ्रॉम दिस, इज परमानेंटली फॉल्स। अगर ये फॉल्स हो गया इसका मतलब यहां से कुछ भी सिलेक्ट नहीं हुआ, ये फॉल्स हो गया इसका मतलब यहां से कुछ भी सिलेक्ट नहीं हुआ। अब अगर मैं बोल रहा हूं एंड, तो ये वाली चीज फॉल्स हो गई, ये वाली चीज फॉल्स हो गई। सुनना अच्छे से, ये वाली चीज फॉल्स हो गई, ये इतना ही था। सुनो 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 सर, अगर ये फॉल्स हो गई तो देखना सर, ये वेयर कंडीशन कहां से कहां शुरू हुई थी, वो इंटरेस्टिंग फैक्टर था। वेयर TA dot goal should be greater than, TA dot goal should be greater than all of them, TA dot goal should be greater than all of them, and TA dot goals must be greater than any of them. सुनिएगा, तो सर अगर ये फॉल्स है, अगर ये फॉल्स है, therefore empty. So my question is, अगर इनर क्वेरी रिजल्ट का इनर क्वेरी रिजल्ट एम्प्टी है, देन ऑल विल ऑलवेज रिटर्न ट्रू। इसका मतलब अब कंडीशन कहां पर आ जाएगी सर, अगर ऑल ऑलवेज रिटर्न ट्रू करेगा तो सिर्फ वो टपल सिलेक्ट होंगे जिनके लिए सेकंड वाली क्वेरी का आउटपुट ट्रू होगा। अगर ऑल हमेशा ट्रू रिटर्न कर रहा है तो ट्रू एंड विथ ट्रू विल बी ट्रू, ट्रू एंड विथ ट्रू विल बी ट्रू, यस और नो। तो अगर ये ट्रू है, अगर ये ऑल हमेशा ट्रू कर रहा है, तो वेयर क्या चेक करेगा सर, पहले वाली क्वेरी का रिजल्ट चेक करेगा, एंड करेगा सेकंड वाली के साथ। जब दोनों का रिजल्ट ट्रू होगा, जब जिस टपल ऑफ टीए के लिए दोनों का रिजल्ट ट्रू होगा वो उसको सिलेक्ट कर लेगा, जिस टपल ऑफ टीए के लिए दोनों का रिजल्ट ट्रू होगा वो उसको सिलेक्ट कर लेगा। तो आपका जो पहला वाला है ये तो सबके लिए ट्रू है, तो इसके रिस्पेक्ट में कोई चेक करने की जरूरत ही नहीं है। वो टपल्स जिनके लिए सेकंड कंडीशन ट्रू होगी, वो टपल्स जिनके लिए सेकंड कंडीशन ट्रू होगी, वो वाले सिलेक्ट होंगे। सो TA डॉट गोल्स मस्ट बी ग्रेटर देन ऑल ऑफ देम who have scored the goals from Spain, but वो empty है, ठीक है। अब बोल रहा है TA डॉट गोल्स, तो आपने जो बाहर से डबल उठाया है that should be greater than TA डॉट गोल्स should be greater than any of TA डॉट गोल्स should be greater than TA डॉट गोल्स should be greater than any of select TC डॉट गोल्स from top scorer TC। हमने एक और बार इसको रीनेम किया, हमने इसको बोला TC from TC where T dot country equals to Germany। सो हमने क्या किया सर, जर्मनी के जो गोल्स हैं हमने वो निकाले। सो कहां कहां पर है जर्मनी, सर जर्मनी यहां पर है, जर्मनी यहां पर है, जर्मनी यहां पर है, ठीक है, जर्मनी यहां पर है और जर्मनी यहां पर है। तो यहां से जो आउटपुट मिला सर, यहां से जो आउटपुट मिला, सो जर्मनी के जो गोल हैं वो कितने हैं सर, जर्मनी के गोल हैं 16, 15, 11, 10, 10, राइट। सो अब आपके सुनना अच्छे से सर, आपके टीए के अंदर के वो टपल्स जिनके अंदर गोल्स इनमें से किसी ना किसी से ज्यादा हैं, टीए के अंदर के वो टपल्स जिनके अंदर गोल्स इनमें से किसी ना किसी से ज्यादा हैं, वो सिलेक्ट होंगे। तो देखना सर, टीए से जब मैंने ये पहला वाला टपल उठाया तो क्या 16 ग्रेटर देन इनमें से किसी से ज्यादा है, हाँ सर 16 एटलीस्ट 15 से ज्यादा है, तो ये सिलेक्ट हो गया। सर क्या 15 इनमें से किसी से ज्यादा है, हाँ सर। अब बात समझना सर, ये 10 वालों को छोड़ करके, क्योंकि 10 इज नॉट ग्रेटर देन एनी ऑफ देम, सर 10 is not greater than any of them, this another 10 is not greater than any of them, any of them, any of them, any of them, any of them. So 16 will be at least greater than 10, 15 will also be at least greater than 10, 14 will be at least greater than 10, 13 will be at least greater than 10, 12 will be at least greater than 10, 11 will be at least greater than 10, 11 will be at least greater than 10. So कितने टपल सिलेक्ट होंगे यहां से, how many tuples will get selected? Sir, the number of tuples written by the above SQL query will be all these tuples in which the number of goals are more than 10. अच्छा ये 14 है, कोई बात नहीं, आई मीन कॉन्सेप्ट तो यहां पर मिनिमम का था। सर जो मिनिमम वैल्यू है उससे ज्यादा जितनी भी वैल्यू है वो सारे टपल सिलेक्ट हो जाएंगे, जो मिनिमम वैल्यू है उससे ज्यादा जितनी भी वैल्यूज हैं वो सारे के सारे टपल सिलेक्ट हो जाएंगे। सो द आंसर विल बी 7। क्लियर। ये वाली कंडीशन परमानेंटली ट्रू थी, तो आपको सिर्फ इस पे फोकस करना था कि ये वाली कंडीशन किसके लिए ट्रू है। पहली वाली कंडीशन सबके लिए ट्रू थी, क्या बोला था, इफ इनर क्वेरी रिजल्ट इज एम्प्टी ऑल विल ऑलवेज रिटर्न ट्रू। तो ये ऑल तो एम्प्टी के साथ सर 16 ग्रेटर देन ऑल ऑफ देम, हाँ जी, क्योंकि कोई है ही नहीं जिसके लिए ग्रेटर देन फेल हो जाए। 15 ग्रेटर देन ऑल ऑफ देम, यस सर। 10 इवन ये जो 10 है 10 ग्रेटर देन ऑल ऑफ देम, सर यहाँ कोई होता जिससे वो बड़ा नहीं होता तो बात करता ना, कोई है ही नहीं, तो 10 ग्रेटर देन ऑल ऑफ देम एज वेल। क्लियर। चलिए नेक्स्ट, दिस दी क्वेरी विथ क्लॉज, जो मैंने आपसे कहा था। सिर्फ विथ कैसे काम करती है इसको समझ लो। जर्मनी को क्यों एक्सक्लूड करेंगे भाई, काहे एक्सक्लूड करेंगे बाबा, आप समझते नहीं हो। सर एक बार ये टेबल टीए ट्रीट होगी तब सारे टपल्स के साथ कंपैरिजन होगा, एक बार ये टीबी ट्रीट होगी तब भी सबके साथ कंपैरिजन होगा। तो हमारी ये जो क्वेरी है, हमने जब इसको एक बार टीए कंसीडर किया है, इसके अंदर जब पहला टपल ले रहा हूं तो यहाँ पर अंदर वाली ये जो क्वेरी है ये तो इंडिपेंडेंट क्वेरी है ना, तो ये जो इंडिपेंडेंट क्वेरी है, ये इंडिपेंडेंट क्वेरी तो ये रिजल्ट प्रोड्यूस कर रही है। तो आपके बाहर वाले टपल में जो गोल हैं वो इस इनर क्वेरी ने जो रिजल्ट प्रोड्यूस किया है उनमें से किसी ना किसी से ज्यादा होना चाहिए। कौन है ये, शांतनु, काहे भाई क्यों इग्नोर करना चाह रहे हो उसको। ठीक है, चलिए विथ क्लॉज वाले क्वेश्चन को समझ लेते हैं फटाफट से। आओ विथ को समझते हैं। ओके चलो सर, अरे कोई मोबाइल का क्या कर रहे हो, मोबाइल से क्या होता है, आओ यहाँ पर देखो फटाफट से। चलो सर, बहुत ही इट्स डैम इजी क्वेश्चन, इट इज अ डैम इजी क्वेश्चन इफ यू नो द बेसिक कॉन्सेप्ट ऑफ विथ क्लॉज। लिसन टू मी वेरी केयरफुली, इट्स अ डैम इजी क्वेश्चन if you know the basic concept of with clause. Okay, so generally what did I say, how does as works? Sir, if we are using only as, then whatever is written before as will be renamed by the term which is written after as. Please try to understand, whatever is written before as, the output of that will be renamed as the name by the term which is written after as, right? But if we use with clause, along with clause as will behave differently. Along with clause, हाँ जी बिल्कुल क्लास का क्वेश्चन है, along with clause this will behave differently. It's a PYQ. So PYQ, so क्लास में PYQ हो गया तो यहाँ भी कराऊंगा ना, क्योंकि रिवीजन है और with clause का एक ही क्वेश्चन है, तो what can I do? है ना? So with clause, okay, please try to understand. Generally these subquery are written, hello, generally these subquery are written after main query. Generally these subqueries are written after main query, but with clause subqueries are written before main query. Listen to me very carefully. So first this is your main query, this is your subquery. This outer query is your main query, this is your subquery, this is your subquery. So subqueries are written inside, but subqueries are written inside, but outer query is your main query which is written outside. But in case, that means first outer query will appear or first main query will appear, within that main query subqueries will appear. First main query will appear, within that main query subqueries will appear. But when we talk about with clause, then all the subqueries that are using with clause will appear before main query. All the subqueries that uses with clause will appear before main query, right? So please try to understand how exactly it will work. Sir, let's assume this is your main query. This is your main query. So in your main query you will have something like select, etc. महाअभ्यास है 7 PM, नहीं, महाअभ्यास will be rescheduled for 9 PM. लंच डिनर वगैरह कर लेना अपना, अदरवाइज बैक टू बैक आपके लिए भी मुश्किल होगा, मेरे लिए भी मुश्किल होगा, है ना, और इसको भी बीच में छोड़ के भागना पड़ेगा. सो विल फर्स्ट कंप्लीट दिस, देन यू विल हैव योर डिनर break and then we'll discuss, then we'll have महाअभ्यास. Okay, sir, with clause. So in the end you will have your main query and initially you will have your subquery with clause. So what will happen? So we'll say with, listen to me very carefully. So why do we use with clause? So using with clause, queries will become simple. You may think that things are becoming difficult, but queries will become simple. Okay, so what will happen? with clause is used to provide subquery block a name that can be used by main query and or queries that follows. Okay, so what will happen? So you will specify with. So with will be used along with as. Please try to understand. You will have with and you will have as. You will have with, you will have as. After as, you will have a subquery. We'll have a subquery after as, okay, and after this with clause, you will have please try to understand. Is it not the definition of a schema? Is it not the definition of a schema? I'm not saying that it will be present throughout the execution, but it will be present only during the execution. Sir, name of the table and the order in which the attributes will appear is nothing but new schema, right? So a new schema will be defined. So please try to understand. So you will have this subquery, output of this subquery. So please try to understand what will happen. This subquery will execute whatever result is produced by this subquery. Hello, this subquery will execute whatever result is produced by this subquery. That result will be given a new name. That result will be given a new name, and that name is defined with clause. So whatever output is produced by this particular query, so output of this query will be given a new name by with clause. पता नहीं. So whatever output is produced by this subquery, उस आउटपुट को एक नया नाम मिलेगा, और वो नाम क्या मिलेगा, वो नाम मैंने विथ क्लॉज के साथ डिफाइन किया हुआ है. ठीक है. सो प्लीज ट्राई टू अंडरस्टैंड. इट्स अ सिंगल, it is a single subquery with clause. We may have other subqueries in the end we'll have main query. In the end we'll have main query. So whatever this with clause or the new schema which is being aliased by this with clause, that particular schema can be referenced by the queries that follows or can be referenced by the main query, can be referenced by the subqueries that follows or can be referenced by the main query. Sir, as of now it may not be clear to you, but you will understand with this particular example. Now let's look at this question. Consider the following database table named as water schemes. So there is a table called water schemes. How exactly it will work? Sir, number of tuples written by the following SQL query will be what? Sir, we have with clause. This is a with clause. After with you will have this as clause. So after this, what will after as there is a query, select district name, comma, sum of capacity from water scheme group by district name. So it's a subquery. Clear? So what output will be produced by this subquery? Please tell me. What output will be produced by this subquery? Fast. What output will be produced by this subquery? Check. Sir, there is a subquery. Let's execute this subquery. What did I say? Sir, with clause you will use as. After the as clause you will have a subquery. The output of that subquery. Come on, I am not looking for the answer. Output of this subquery will be assigned a new name. Output of the subquery will be assigned a new name by this with clause. Output of the subquery will be assigned a new name by this subquery. So what exactly will be produced, sir? What is the order of execution? First of all, you will select the water scheme table. You have selected water scheme table. No where clause. Therefore, all the tuples will get selected. Then you will create group based on distinct name. So one group that will get created will be Ajmer. Another group that will get created will be Bikaner. Another group that will get created will be Churu. Another group that will get created will be Dungargarh. So this 5 groups will be created. Then no having condition, therefore all 5 groups will be selected. Then you will have, sir, aggregate function is being used in the select clause, but along with the select clause, along with the aggregate function, you are specifying an attribute in the select clause, but it's perfectly fine. It is perfectly fine because that attribute is present in the group by clause. Because that attribute is present in the group by clause. So in the output you will get 2 things. Sir, in the output you will get district name. मैं इसको short कर दे रहा हूँ because I don't have enough space, and you will have sum of capacity. So the output will be this. Sir, 4 districts, one will be Ajmer. First will be Ajmer. Now, if you have group by clause, then aggregate function will be applied on each group. So the capacity of Ajmer will be summed up. So you will get the answer as, the summation of the capacity of Ajmer district is 20. So summation of the capacity of Bikaner district is 40. Then summation of the Churu district is 30 actually, 30. And summation of Dungargarh, again only 1, and the summation of the capacity will be the value of that single tuple. Okay. Now please try to understand. So this subquery will execute and it will produce this output. Now what did I say? The output of this subquery will be given a new name, and that new name or the new schema is defined by this with clause. So this will be given a new name. The name of the table will be total. Name of the table will be total. First attribute will be called name, and the second attribute will be called capacity. So district name will become name, and sum of capacity will become simply capacity. Got the idea? So this is what you will get because of execution of this first subquery. So because of execution of this first subquery, this total table will come into the picture, and it will not remain forever. Please try to understand, it will not remain forever, it will remain only during the execution of this query. It will remain only during the execution, or the alias will exist only during the execution of query. As soon as the execution of query is completed, the alias will go away, right? So next, sir, done with the first subquery? Please tell me, the execution of the first subquery is clear to everyone, or you have any confusion? Because of this execution of this first subquery, this total table will be created, which will have two attributes, name and capacity. Then after this, you will go and you will execute the second subquery. After that, you will go and you will execute the second subquery. Now what will happen? Again, second subquery. So first of all, what is the order of execution? What is the order of execution? First of all, select from total. So this is the first thing, from total. So this total table will be selected. This total table will be selected. No where condition, no group by, nothing. So all the tuples of the total will be present, and then you will select the average of capacity. So when somebody asks that what output will be produced by this particular query, so the output of this particular query will be average of capacity now. If no group by clause is, if no group by is present, then the aggregate function will be applied on the complete table. So there will be only one attribute, average capacity, and it will be nothing but 20 plus 40, 60 plus 30, 90 divided by 90 plus 10 divided by 4. So this average capacity will come out as 25. So this is the output of this blue color query, but it will be given a new name using this with clause. So what will happen? Sir, this total average will be the name given to this table. Total average will be the name given to this table, and there will be only one attribute, and it will be renamed by capacity. Right? So this is the new table that will get created because of execution of this second subquery. So first subquery will produce this table total, second subquery will produce this table total average. Make sense? Then what? Sir, then finally this main query will execute. So this is the first thing that will execute, this is the second thing that will execute, this is the third thing that will execute. So generally we start from main query, but when we use the with clause, we will first execute all the subqueries that uses with clause, and finally we will execute the main subquery. Clear? So what will happen? Sir, what is the order of execution? What is the order of execution? First of all, we will perform the Cartesian product of total and total average. First of all, we'll perform the Cartesian product of total and total average. So what will happen? Sir, you will have total, just for understanding purpose, you will have total cross total average. So you will have all the attributes of total followed by all the attributes of total average. So in the total, you have total dot name. Then you will have total dot capacity. Then you will have attributes of total average. So you will have total average dot capacity. Now what will happen? Sir, all the attributes of total will be combined with all the attributes of total capacity. So Ajmer 20 will be combined with 25. Bikaner 40 will be combined with 25. Churu 30 will be combined with 25. Then Dungargarh 10 will be combined with 25. So this table will come into the picture because of the Cartesian product of total and total average. Okay. Then after that, You will perform the where condition. So where condition will say total dot capacity must be greater than or equals to total average dot capacity. So total dot capacity, so it will not get selected. Bikaner total dot capacity is greater than total average dot capacity. Total dot capacity is greater than total average dot capacity. Total average, so this is greater than no, this is greater than yes, this is greater than yes, this is not greater than, right? So this two will get selected, other two will not get selected. So two tuples will get selected, and from those two tuples, you will get the name, and in the name you will get Bikaner and Churu. Make sense? Clear? So this may look difficult, that sir I don't know what this with clause is, but it is damn easy. Whatever is written after the as clause, that will be considered as a subquery. That subquery will execute, and the output of the subquery will be given a new name using the schema defined with clause, and the following query will use that particular thing. सर रिलेशनल अलजेब्रा के क्वेश्चन सॉल्व होते बट एसक्यूएल क्वेश्चन बन जाते हैं क्या? ये एक ही बात कर रही हो आप? दोनों के बन जाते हैं कह रही हो? डन. This is also for paid class students. This is also the example that I have discussed in the class. But this is the very first example of correlated subquery. Check. Tell me what output will be produced by this particular query. What output will be produced by this particular query? Past. Tell me. Okay. Let's look at this. Consider the relational database with the following four schemas. So we have a student table, one department table, one course table, one register table, right? So in the student table, we have the student number, which will be the key. In department table, we have the department number, which will be the key, that we can actually observe that department number, all the department numbers are unique. They are underlined actually. So here, on the paper, they were underlined. So don't worry about that. Okay. Course table, we have the course number as key, and register table, we have student number and course number together as a key. So these two together will define the key. Now, there is a query that executes. So what happens? Sir, select asterisk from student as S. So this student table is renamed as S, where not exists. Sir, not exists will return true if inner query result is empty. Inner query result is empty. सर विथ क्लॉज में रिलेशन के साथ एट्रीब्यूट देना, रिलेशन के साथ एट्रीब्यूट नहीं 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 नहीं, पूरा स्कीमा डिफाइन करना पड़ेगा भाई, स्कीमा डिफाइन करना पड़ेगा. ठीक है, चले प्लीज ट्राई टू अंडरस्टैंड. देयर आर टू पोर्शन. सर एक्सेप्ट इज एक्चुअली सेट डिफरेंस और माइनस. So there are two subqueries. One is this select C number from course where department number equals to D1. So what exactly will be produced by this particular query? So it will produce the course, or it will produce the course number of all the courses of department D1, D01. So if we look at the output, what will be the output? Sir, the only two courses which are from department D01 are C11 and C12. The courses are C11 and C12. There is another query which is this: select C number from register where S number equals to S dot S number. Come on, that's the beauty. So what is the beauty? Sir, this is S is the relation outer query, and this S dot S number attribute from relation in outer query. Therefore, what type of query is this? Correlated query, and this is an independent query. So to execute this query, we only need the course table and we don't need anything else. So this is independent subquery. So independent subquery will be executed fast and it will produce the output as C11 and C12. Independent subquery will execute fast and it will produce the output as C11 and C12. Then with respect to each tuple of student table, what will we do? So with respect to each tuple of student table, this the second part of the inner subquery will be executed. That is, we'll select the C number from the register table where in the register table we have the attribute S number. So in the register table we have this attribute S number. So this attribute S number of the register table must be equals to S dot S number. This is S dot S number of the table student. So first of all, we'll select one tuple. So what is the order of execution? What is the order of execution? Sir, from student S will select the first tuple. So from student S will select the first tuple and we'll go to this register table. First of all, we'll select the first tuple. So how, sir? We will compare with the first tuple and we'll see that if S dot S number is S01, here also S number is S01, therefore the condition is equal. So if the condition is equal, then where condition will be true, and if where condition is true, then course number will be selected. So with respect to S01, the course number that will get selected will be, please try to understand, with respect to S01, the course number that will get selected will be C11 and S01 will have C12. Right? Now, sir, none of these tuples will get selected because in the first tuple S dot S number is S01 and in the other tuples of register table S number is not equals to S01. Clear? Okay. So then, sir, we have scanned the complete register table and in the output with respect to first tuple we will get C11 and C12. In the output with respect to first tuple we will get C11 and C12. So this is actually the output. Whatever we see here is actually the output with respect to this second query. So this second query will produce C11, C12 with respect to first tuple. This query will produce with respect to second tuple of student table. So S number should be S02. So S number is S02. So it will produce only C11. With respect to S03, it will produce C21, C22, C23, C21, C22. जगह ही नहीं है यार. C21, C22, C23. With respect to S04, it will produce C11, C12. Then, with respect to S05, it will produce C11, C21. Then what will happen? Sir, from C11, C12, when we subtract C11, C12, result will be 5. So, the result of this accept. Sir, from C11, C12, if we subtract C11, C12, then this whole query will produce the result So after the subtraction, this will produce 5. So from C11, C12, if we subtract C11, you will get C11. You will get C11. Okay. From C11, C12, if we subtract 21, 22, 23, you will get C11, C12. From C11, C12, if we subtract C11, C12, you will get 5. From C11, C12, if you subtract C11, C21, then the only thing that left is C12. So, please try to understand empty. So, when result is empty, not exists will return true. When result is empty, not exists will return true. So, not exists will return true with respect to S01 and S04. Not exists will return true S01 and S04. Therefore, two tuples in output. So, number of tuples produced. Is it clear to everyone? S02, C12 returns. S02, C12, C11, C12 minus C11. Yes, thank you. Is it even visible? मुझे यहीं से दिखाई नहीं दे रहा, आपको तो क्या ही दिखाई दे रहा होगा. मुझे यहीं से दिखाई नहीं दे रहा, आपको तो क्या ही दिखाई दे रहा होगा. C11, C12 minus C11, result will be C12. C11, C12, so this will be C11, 12. This will be pi. C11, C12 minus C11, C21 will be C12. Done? Okay, so I hope you understand that, sir, with respect to independent subquery, we will execute it, we'll get the result. But if it is a correlated subquery, we'll execute it tuple by tuple. If query is a correlated subquery, so we'll first execute with respect to first tuple, then we'll execute with respect to second tuple, then we'll execute with respect to third tuple, and so on. When if it is independent, we'll execute it and we'll get the result of that independent subquery. Clear? Okay, so the last question of this session. Tell me. So given the following schema, employees is our table, employee ID, first name, last name, hire date, department ID, salary are the attributes. Sir, इसमें only exist use होता है तो S2 and S3 select होता. अरे आप एक चीज समझने की कोशिश करो कि ये क्वेरी कर क्या रही है. कभी कभी हम लोगों से, ये तो चलो हमने यहाँ पर आपसे नंबर ऑफ टपल्स पूछ लिए, ये क्या कर रहा है? सर, ये जो बता रहा है, ये आपको बता रहा है that all the courses of C11 C12, सुनिएगा, ऑल दी कोर्सेज ऑफ C11 C12। देन यहाँ पर क्या बता रहे हैं सर, हम S नंबर इक्वल टू एस नंबर को देख करके, जहां पर रजिस्टर टेबल में S नंबर इक्वल टू S डॉट S नंबर है, वहां से कोर्स नंबर निकाल रहे हैं। इसका मतलब हम वो सारे के सारे कोर्स नंबर निकाल रहे हैं जो किसी स्पेसिफिक स्टूडेंट ने जिनके लिए रजिस्टर किया है। तो S01 ने C11 C12 के लिए रजिस्टर किया है, S02 ने सिर्फ C11 के लिए रजिस्टर किया है, S03 ने 21 22 23 के लिए एनरोल किया है। सो सर, जो कोर्सेज हैं डिपार्टमेंट 01 के, उनमें से हम उन कोर्सेज को हटा रहे हैं जिनके लिए स्टूडेंट्स ने रजिस्टर किया है। सो अगर मैं डिपार्टमेंट D01 के कोर्सेज से उन कोर्सेज को हटाता हूं जिनके लिए स्टूडेंट D01 ने रजिस्टर किया है, तो रिजल्ट या तो एम्प्टी आएगा। अगर रिजल्ट एम्प्टी आ रहा है, इसका मतलब आप जिस स्टूडेंट के करस्पॉन्डिंग रिजल्ट एम्प्टी आ रहा है उसने डिपार्टमेंट D01 के सारे कोर्सेज के लिए रजिस्टर किया है। अगर रिजल्ट नॉन एम्प्टी आ रहा है तो कम से कम एक कोर्स ऐसा है डिपार्टमेंट D01 का जिसके लिए स्टूडेंट ने एनरोल नहीं किया है। दैट्स व्हाट इज बीइंग डन। तो ये क्वेरी क्या प्रोड्यूस कर रही है सर? ये क्वेरी उन स्टूडेंट्स के नाम प्रोड्यूस कर रही है जिन्होंने डिपार्टमेंट D01 के सारे कोर्सेज के लिए एनरोल किया है। If I give the option as that this produces the output of the, or the query produces the S name of the students who enrolled for all the courses of department D01, for some courses of department 01, at least one course of department D01 did not enroll for any course of department D01 and so on। तो ऐसे में चार ऑप्शन और बना सकता हूं। तो आपको इसको इंटरप्रीट करना है कि क्या कर रहा है। सबसे पहले डिपार्टमेंट D01 के सारे कोर्स नंबर, है ना, डिपार्टमेंट D01 के सारे कोर्स नंबर। उसके बाद हमने देखा कि डिपार्टमेंट D01 के सारे कोर्स नंबर एंड देन कोर्सेज जिसके लिए उन्होंने एक्चुअल में एनरोल किया था। तो अगर सब्ट्रैक्शन के बाद पाई आ रहा है, इसका मतलब उसने डिपार्टमेंट D01 के सारे कोर्सेज के लिए एनरोल किया है। अगर सब्ट्रैक्शन के बाद पाई नहीं आ रहा है तो कम से कम एक ऐसा कोर्स है डिपार्टमेंट D01 का जिसके लिए उसने एनरोल नहीं किया है। तो अगर आप यहाँ पर एग्जिस्ट यूज करते तो जिनके लिए नॉन एम्प्टी आता वो आते। इसका मतलब अगर आप यहाँ पर एग्जिस्ट यूज करते तो आपको आउटपुट में वो स्टूडेंट के नेम मिलते जिन्होंने डिपार्टमेंट D01 के कम से कम एक कोर्स के लिए रजिस्टर नहीं किया है। तो कौन कौन है जिन्होंने नहीं किया है सर? डिपार्टमेंट D01 में C11 C12 में, S2 ने C12 के लिए नहीं किया है तो ये आउटपुट आता। सर S03 ने किसी के लिए भी एनरोल नहीं किया है इसलिए ये भी आउटपुट में आता। सर S04 ने सबके लिए किया है इसलिए ये नहीं आता। S05 ने भी कम से कम C12 के लिए नहीं किया इसलिए ये भी आता। तो S2 S3 एंड S5 आपको आउटपुट में मिलता अगर यहाँ पर एग्जिस्ट है। तो ये वो स्टूडेंट्स के नाम हैं जिन्होंने कम से कम एक कोर्स ऑफ डिपार्टमेंट D01 के लिए एनरोल नहीं किया है। एक ऐसा कोर्स है डिपार्टमेंट D01 में, कम से कम एक ऐसा कोर्स है डिपार्टमेंट D01 में जिसके लिए उन्होंने एनरोल नहीं किया है। ठीक है, लेट्स लुक एट दिस क्वेरी। सो एम्प्लॉय टेबल है, वहां पर एम्प्लॉय की आईडी है, फर्स्ट नेम लास्ट नेम हायर डेट डिपार्टमेंट सैलरी सब कुछ है। डिपार्टमेंट टेबल है जहां पर डिपार्टमेंट की आईडी है। देखो एम्प्लॉय टेबल में एम्प्लॉय की हायर डेट है और वो किस डिपार्टमेंट में काम करता है उसकी इंफॉर्मेशन है। डिपार्टमेंट टेबल में डिपार्टमेंट की आईडी है, डिपार्टमेंट का नाम है, मैनेजर की आईडी और उसकी लोकेशन है ना। अच्छे से इंफॉर्मेशन समझो। यू वांट टू डिस्प्ले, अभी देखो ये बड़ी प्यारी क्वेरी है, इन्होंने सब कुछ लिख के दिया है। यू वांट टू डिस्प्ले, हमको डिस्प्ले करना मांगता। वी वांट टू डिस्प्ले दी लास्ट नेम्स, क्या लास्ट नेम्स एंड हायर डेट्स। हमको लास्ट नेम चाहिए और हायर डेट चाहिए किसकी? वी वांट टू डिस्प्ले दी लास्ट नेम एंड हायर डेट्स ऑफ ऑल लेटेस्ट हायर्स। लेटेस्ट हायर्स मींस सर लेटेस्ट हायर कौन होगा सर? जिसकी हायर डेट मैक्सिमम होगी। तो लेटेस्ट हायर मींस max of hire date, right, in their respective department. So we want to display the last name चाहिए हमको और hire date चाहिए हमकी उस of all the जो सबसे लेटेस्ट हायर्ड जो एम्प्लॉई हैं उनका लास्ट नेम और वो किस डेट को हायर हुए हैं वो इंफॉर्मेशन चाहिए इन देयर रिस्पेक्टिव डिपार्टमेंट्स। तो हमको रिस्पेक्टिव डिपार्टमेंट्स के अंदर जो लेटेस्ट हायर हैं उनकी इंफॉर्मेशन चाहिए इन दी लोकेशन आईडी 1700। हमको हर डिपार्टमेंट से भी लेटेस्ट हायर्स नहीं चाहिए, हमको सिर्फ उन डिपार्टमेंट से लेटेस्ट हायर का नाम और उसके लेटेस्ट हायरिंग डेट चाहिए है जो डिपार्टमेंट लोकेशन आईडी 1700 पर हैं। ठीक है, तो सर डिपार्टमेंट की जो लोकेशन आईडी है सबसे पहले तो वो 1700 होनी चाहिए। तो 1700 के करस्पॉन्डिंग जो जो डिपार्टमेंट आईडी हैं उन डिपार्टमेंट आईडी के करस्पॉन्डिंग जो एम्प्लॉई हैं उनके अंदर ग्रुपिंग करो बेस्ड ऑन डिपार्टमेंट आईडी, उनके अंदर ग्रुपिंग करो बेस्ड ऑन डिपार्टमेंट आईडी और वहां से मैक्सिमम ऑफ हायर डेट निकालो, वहां से मैक्सिमम ऑफ हायर डेट निकालो। तो हमने किया क्या, देखना यहां से इस क्वेरी को, ये हमको ये क्वेरी तो गिवन होगी, मैं आपसे ऑलरेडी बोला हूं। तो क्या बोल रहा है, सिलेक्ट लास्ट नेम एंड हायर डेट, हमको लास्ट नेम चाहिए है, यही पूछा गया है, एंड हायर डेट पूछी गई है फ्रॉम एम्प्लॉई। ठीक है, तो हमको एम्प्लॉय टेबल में लास्ट नेम भी मिल जाएगा, हमको एम्प्लॉय टेबल में हायर डेट भी मिल जाएगी, लेकिन मुझे ये हायर डेट है ये कहां से चाहिए इसको समझते हैं। ठीक है, फ्रॉम एम्प्लॉइज वेयर डिपार्टमेंट आईडी, आपका जो टेबल है एम्प्लॉय टेबल उसके अंदर डिपार्टमेंट आईडी और जो हायर डेट है, डिपार्टमेंट आईडी और जो हायर डेट है वो कहां पर होनी चाहिए सर, वो होनी चाहिए इस सेट ऑफ टपल्स में, वो होनी चाहिए इस सेट ऑफ टपल्स में। अब इस इनर क्वेरी को देखो ये कर क्या रहा है, इस इनर क्वेरी को देखने की कोशिश करो ये कर क्या रहा है। सर सिलेक्ट डिपार्टमेंट आईडी एंड मैक्स हायर डेट, सर एग्रीगेट फंक्शन के साथ, एग्रीगेट फंक्शन के साथ एट्रीब्यूट यूज हो रहा है, तो उस डिपार्टमेंट आईडी का, एग्रीगेट फंक्शन के साथ एट्रीब्यूट डिपार्टमेंट आईडी यूज हो रहा है, तो उस डिपार्टमेंट आईडी का ग्रुप बाय क्लॉज में प्रेजेंट होना जरूरी है, सो दैट मैं हर डिपार्टमेंट की मैक्सिमम हायर डेट निकाल पाऊं। लेकिन मुझे सारे के सारे डिपार्टमेंट की हायर डेट मैक्सिमम और मैक्सिमम हायर डेट नहीं चाहिए, मुझे सिर्फ उन डिपार्टमेंट्स की मैक्सिमम हायर डेट चाहिए हैं जो लोकेशन आईडी 1700 पे हैं। तो सबसे पहले जो डिपार्टमेंट आईडी के बेसिस पे ग्रुप बनेंगे वो सारे के सारे डिपार्टमेंट्स के नहीं बनेंगे, सिर्फ उन डिपार्टमेंट्स के बनेंगे जो लोकेशन आईडी 1700 पर हैं। तो सबसे पहले मैं क्या करूंगा कि फ्रॉम एम्प्लॉई जॉइंट डिपार्टमेंट, इसका मतलब सर ये इसलिए कर लिया हमने, क्यों कर लिया समझिएगा कि सर यहाँ पर जो डिपार्टमेंट आईडी है और यहाँ पर जो डिपार्टमेंट आईडी है वो सेम होनी चाहिए। अगर मैं जॉइन बोल रहा हूँ इन दोनों के बीच में एक ही कॉमन एट्रीब्यूट है, इन दोनों के बीच में एक ही कॉमन एट्रीब्यूट है डिपार्टमेंट आईडी, तो डिपार्टमेंट आईडी के बेस में जॉइन हो जाएंगे। कौन सा एम्प्लॉय किस डिपार्टमेंट आईडी का है, वो डिपार्टमेंट आईडी किस लोकेशन का है, ये हमको पता चल जाएगा। तो हमने बोला कि एम्प्लॉय और डिपार्टमेंट का जॉइन परफॉर्म करो, उस जॉइन के बाद वो सारे टपल्स जिनके अंदर लोकेशन आईडी 1700 है, वो सारे टपल्स जिनके अंदर लोकेशन आईडी 1700 है। देखो ये जो यूजिंग है ये अलग अलग जगह पे है, कुछ सर्वर्स इसको अलाउ करते हैं, कुछ सर्वर्स अलाउ नहीं करते। तो ये बोल रहा है कि हमको ज्वाइन करना है डिपार्टमेंट्स को बेस्ड ऑन डिपार्टमेंट आईडी। अगर मैं सीधे सीधे नेचुरल ज्वाइन लिखता तो ये डिपार्टमेंट आईडी के बेसिस पे ही ज्वाइन होता है ना, या तो मैं लिख सकता था कि सीधे लिख देता फ्रॉम एम्प्लॉय कॉमा डिपार्टमेंट्स और उसके बाद बोल देता एम्प्लॉय डॉट डिपार्टमेंट आईडी इक्वल्स टू डिपार्टमेंट्स डॉट डिपार्टमेंट आईडी, ये वेयर की कंडीशन हो जाती है ना। तो ये सारी चीजें चलती हैं कि हमने एम्प्लॉय और डिपार्टमेंट्स को क्लब किया है, एम्प्लॉय जिस डिपार्टमेंट में काम करता है उस डिपार्टमेंट का जो लोकेशन आईडी है वो 1700 होना चाहिए। तो ऐसे एम्प्लॉय जो 1700 लोकेशन आईडी वाले डिपार्टमेंट में काम करते हैं उनके करस्पॉन्डिंग डिपार्टमेंट के बेसिस पे ग्रुप कर लो, ठीक है, और फिर ये निकाल लो कि डिपार्टमेंट के बेसिस पे जो हायर डेट है वो मैक्सिमम किसके लिए है, डिपार्टमेंट के बेसिस पे जो मैक्सिमम हायर डेट है वो किसके लिए है। अब बात समझना सर, यहां पर हमारे पास इसके अंदर डिपार्टमेंट आईडी आई है, उसकी मैक्सिमम हायर डेट आई है, इसका मतलब एक डिपार्टमेंट उसकी जो मैक्सिमम हायर डेट है वो मिल गई है, ठीक है। तो एम्प्लॉय टेबल में डिपार्टमेंट आईडी और मैक्सिमम हायर डेट जिससे भी मैच करेगी, अगर जिस एम्प्लॉय के करस्पॉन्डिंग डिपार्टमेंट आईडी और हायर डेट, जिस एम्प्लॉय के करस्पॉन्डिंग डिपार्टमेंट आईडी और हायर डेट, जिस एम्प्लॉय के करस्पॉन्डिंग डिपार्टमेंट आईडी और हायर डेट इज डिपार्टमेंट आईडी एंड मैक्स ऑफ हायर डेट से मैच करती है, वो एम्प्लॉय उस पर्टिकुलर डिपार्टमेंट का लेटेस्ट हायर्ड है। तो हम बोलेंगे डिपार्टमेंट आईडी एंड हायर डेट मस्ट बी इन दिस सेट ऑफ टपल। सर यहां पर ये सिलेक्ट क्लॉज दो वैल्यूज को प्रोड्यूस कर रहा है, डिपार्टमेंट आईडी एंड मैक्स हायर डेट, ठीक है। तो मैं डिपार्टमेंट आईडी एंड हायर डेट का जो टपल है उसको देखूंगा कि क्या वो टपल इस सेट ऑफ टपल्स में है जो इस इनर क्वेरी ने प्रोड्यूस किया है, राइट। सो यस, ये वही काम करने की कोशिश कर रहा है कि जो डिपार्टमेंट आईडी है और जो हायर डेट है, अगर ये उन डिपार्टमेंट आईडी और हायर डेट के सेट ऑफ टपल्स में हैं जो उस डिपार्टमेंट आईडी का लेटेस्ट हायर है, तो उस डिपार्टमेंट आईडी का इस लेटेस्ट हायर डेट वाला जो एम्प्लॉय है उसका मुझे लास्ट नेम चाहिए और उसकी हायर डेट चाहिए। तो हमने क्या बोल दिया सर अगर ये वाली कंडीशन, इसका मतलब ये आपके एम्प्लॉय टपल का जो डिपार्टमेंट आईडी और हायर डेट, ये जो उस डिपार्टमेंट के लेटेस्ट हायर डेट है उसके अंदर है, तो वो टपल आपका, वो एम्प्लॉय आपका लेटेस्ट हायर है, तो आप वहां से उस एम्प्लॉय का लास्ट नेम और उस एम्प्लॉय की हायर डेट आउटपुट में डाल दीजिए। वेरी कॉम्प्लिकेटेड क्वेरी, आई कंप्लीटली अंडरस्टैंड दैट इट्स अ वेरी कॉम्प्लिकेटेड क्वेरी, बट गिवन दी क्वेरी आप इसको इंटरप्रीट कर सकते थे। ऐसी कोई चीज नहीं है जो हमको नहीं पता है। हम टपल वाइज कंपैरिजन कर सकते हैं, बिल्कुल पूरे के पूरे टपल को whether this tuple is in this set of tuples or not कंपेयर कर सकते हैं। तो उसने वही पूछा है, इट एग्जीक्यूट्स बट डज नॉट गिव द करेक्ट रिजल्ट। बाय भाई, क्यों नहीं देगा? हम जो डिपार्टमेंट आईडी और हायर डेट है उसको उस सेट ऑफ डिपार्टमेंट आईडी एंड हायर डेट से कंपेयर कर रहे हैं जो उस पर्टिकुलर डिपार्टमेंट आईडी की मैक्सिमम हायर डेट है। अब बात समझना, यहां पर हम एक एजम्पशन लेकर के चल रहे हैं जो इस क्वेरी में है कि एक हायर डेट को एक से ज्यादा एम्प्लॉय हायर नहीं हुए होंगे इन सेम डिपार्टमेंट। अगर सेम हायर डेट को एक से ज्यादा एम्प्लॉय हायर हुए होंगे तो उन दोनों का नाम आउटपुट में आएगा। सो मुझे ये बताओ, अगर एक डिपार्टमेंट में एक से ज्यादा एम्प्लॉई सेम डेट पे हायर हुए हैं और अगर उन दोनों की हायर डेट मैक्सिमम है, तो क्या उन दोनों का लास्ट नेम और उन दोनों की हायर डेट आउटपुट में मिलेगी? क्या उन दोनों का लास्ट नेम और हायर डेट आउटपुट में मिलेगी? यस सर, उन दोनों की, क्योंकि ये जो लास्ट नेम और हायर डेट है ये एम्प्लॉय E1 के लिए भी होगी और यही एम्प्लॉय E2 के लिए भी होगी। तो E2 के लिए भी ये जो लास्ट नेम और हायर डेट है ये मैक्स वाले सेट में होगी और E2 के लिए भी ये जो लास्ट नेम और हायर डेट है ये मैक्स हायर डेट वाले सेट ऑफ टपल्स में होगी। इसलिए आपका E1 के लिए भी इन वाली कंडीशन ट्रू आएगी, E2 के लिए भी इन वाली कंडीशन ट्रू आएगी। तो ये वो सारे के सारे एम्प्लॉइज की लास्ट नेम और हायर डेट हमको प्रोवाइड करता है जो उस पर्टिकुलर डिपार्टमेंट का लेटेस्ट हायर है, जो डिपार्टमेंट लोकेशन 1700 पर एग्जिस्ट करता है। सो यस सर, इट विल एग्जीक्यूट एंड इट एग्जीक्यूट बट डज नॉट गिव द करेक्ट रिजल्ट। नो, इट सेज इट एग्जीक्यूट एंड गिव्स द करेक्ट रिजल्ट। हाँ सर, ये एग्जीक्यूट करेगा और करेक्ट रिजल्ट देगा। बाकी जो दो ऑप्शन है वो आप सीधे सीधे मना कर दोगे। इट जनरेट्स एन एरर बिकॉज ऑफ पेयर वाइज कंपैरिजन। क्यों भाई, मैं इस पूरे के पूरे टपल को इस सेट ऑफ टपल में कंपेयर क्यों नहीं कर सकता? यस, मैं कर सकता हूं। सो पेयर वाइज कंपैरिजन इज अलाउड, नो प्रॉब्लम विद दैट। इट जनरेट्स एन एरर बिकॉज ग्रुप बाय क्लॉज कैन नॉट बी यूज विद टेबल ज्वाइन इन सबक्वेरी। अरे ग्रुप बाय क्लॉज को आप कहीं भी यूज करते हो, टेबल ज्वाइन हो रही हो नहीं हो रही हो, आप ग्रुप बाय क्लॉज को हर सिचुएशन में यूज कर सकते हो। आपने ये ज्वाइन करके और उसके बाद आप जिस एट्रीब्यूट के बेसिस पे ग्रुप करना चाहो उस एट्रीब्यूट के बेसिस पे ग्रुप कर सकते हो। तो ऑप्शन डी इज ऑल्सो फॉल्स। क्लियर? तो ऐसा कोई भी अगर स्टेटमेंट होता कि आप इस सिचुएशन में ग्रुप बाय क्लॉज परफॉर्म नहीं कर सकते हो तो मैं आपको डेफिनेटली बताता। अगर मैंने नहीं बताया है इसका मतलब किसी भी सिचुएशन में ग्रुप बाय क्लॉज परफॉर्म, ग्रुप बाय क्लॉज अप्लाई किया जा सकता है। क्लियर? डन? So the correct answer for this query will be option B. So देखो, अगर मैं सिर्फ PYQ में यही सोचता, अगर मैं आपको देखो 3 घंटे का टाइम था, आपको ये भी पता है कि ये सिर्फ मेरे ऊपर रिस्ट्रिक्शन नहीं है, सारे टीचर्स को जो PYQ डिस्कस करने का टाइम मिला था वो 3 आवर्स का टाइम था, है ना? तो अगर मैं 3 आवर्स का टाइम सारे के सारे टॉपिक पे लगाता तो मैं किसी को भी ढंग से कंप्लीट नहीं कर पाता। अगर मैं जो 3 आवर्स का टाइम है ये सारे के सारे टॉपिक्स के PYQ पे लगाता, मान लीजिए मैं ट्रांजैक्शन कॉन्करेंसी कंट्रोल भी ले लेता, मैं बी ट्री बी प्लस ट्री भी ले लेता और फिर मैं TRC VRC के भी क्वेश्चन ले लेता, रिलेशनल अलजेब्रा के भी उसके नॉर्मल फॉर्म के भी और क्वेश्चन ले लेता। तो अगर मैं 2-3 टॉपिक और मिक्स कर देता तो मैं किसी भी टॉपिक के साथ जस्टिस नहीं कर पाता। लेकिन एटलीस्ट अब इस सेशन के बाद हमको ये पता है कि रिलेशनल मॉडल एंड नॉर्मल फॉर्म में जिस जिस टाइप के कॉन्सेप्ट्स हमने पढ़े थे उस टाइप पे कैसे क्वेश्चंस फ्रेम हो सकते हैं और उनको कैसे अप्रोच करना है हमने देख लिया। रिलेशनल मॉडल एंड नॉर्मल फॉर्म इज इजीएस्ट ऑफ एनीथिंग पॉसिबल इन द सिलेबस ऑफ गेट एग्जाम। उससे ज्यादा कुछ है ही नहीं, मतलब उससे आसान कुछ है ही नहीं। ठीक है, उसके अलावा एसक्यूएल एंड रिलेशनल अलजेब्रा जो थोड़ा सा टिपिकल है, अगर मैं इसमें ऊपर ऊपर से क्वेश्चन करा देता तो आपका टाइम भी बर्बाद होता और कोई सिग्निफिकेंस भी नहीं होता। इसलिए आई वाज लाइक कि सिर्फ 2 ही टॉपिक करो लेकिन ढंग से कर लो, सिर्फ 2 ही टॉपिक करो लेकिन ढंग से कर लो। आप लोगों को जो मैक्सिमम स्ट्रगल परफॉर्म करना पड़ रहा है, वो स्ट्रगल हो रहा है वो B3 B+3 में हो रहा है, तो हम उसको जो हमारा सेशन है, कौन सा, महाअभ्यास वाला, उसमें कवर करने की कोशिश करेंगे। ठीक है, चले। सो ये जो 2 टॉपिक मैंने बोले थे, यहाँ पर मैंने ऑलमोस्ट हर कॉन्सेप्ट के ऊपर क्वेश्चन टच किया है। ऐसा होगा थोड़ा बहुत तो, मतलब एकदम बच्चों वाला टॉपिक, लेकिन जो भी इंपॉर्टेंट कॉन्सेप्ट थे वो मैंने सारे के सारे टच किए हैं। सो आई होप जो 2 चीजें हमने कर ली हैं उसमें आप लोगों को सारी चीजें सही से समझ में आई होंगी। सर टेबल कैसे बनाऊं व्हेन गिव्स ओनली एट्रीब्यूट, क्या मतलब, टेबल कैसे बनाऊं? भाई वही तो है, वहां पर किस टाइप की प्रॉपर्टी है एट्रीब्यूट की, उसी को तो सोचना है। अगर की दिया हुआ है तो वो क्या ले सकता है, नल ले सकता है या नहीं, यही चीजें तो सोचनी है। वेयर एम्प्लॉई कमा डिपार्टमेंट डस, क्या बोल रहे हो ये सर, वेयर एम्प्लॉई कॉमा डिपार्टमेंट डज इट मीन ज्वाइन, वेयर नहीं फ्रॉम, सौम्यदीप फ्रॉम एम्प्लॉई कॉमा डिपार्टमेंट मीन्स ज्वाइन ऑफ दिस टू, डोंट से वेयर। अरे पॉल साहब, फ्रॉम एम्प्लॉय कॉमा डिपार्टमेंट मीन्स ज्वाइन, नॉट वेयर। फ्रॉम द अंडरस्टैंडिंग पॉइंट ऑफ व्यू, बिकॉज इट इज नॉन प्रोसीजरल, तो हम अंदर क्या होता है उसकी बात नहीं करते। क्या उल्टी सीधी बातें करते रहते हो। चलो, so that will be all for this session. See you at 9 p.m. with Mahabhyas. Till then, take care, keep learning, have your dinner, prepare yourself. See you at 9 p.m. Bye bye.